Hi everyone.
Hi.
So today is the last day of the DevFest Central Asia, and I'm moderator from GDG Bishkek Mirinjan Zakova. And Sardor is our first speaker for today. Sardor Ismailov.
Hi everyone. I'm glad to be here. I participate in most of the GDG events, so it's my pleasure to participate this year as a speaker also.
So great. So Sardor came us with understanding block architecture in Flutter. So Sardor.
Yeah, sure. So let's start. Thank you, Miriam. I'm gonna share my screen, so hope it's feasible. So let's start. So my today's topic is understanding block architecture in Flutter. So we're going to talk about what's block and why we have to use block and where it came from and how we going to implement that in our production and test codes. So before diving into the topic, a bit about myself. I'm Sardar. I'm a software engineer and freelancer at different companies. I do mobile development for last 5 years, and for the last 2.5 years, I intensively doing the Flutter application for our companies. So what's block? So block is an architecture. It's similar to MVVM, MVI, MVC architectures, but it's mostly related to state management. As you know, Flutter is more similar to React, and in React, we deal with mostly states and state of the application and etc. So what the meaning of the block is that business logic component is architectural pattern based on separate components. So block components contain only business logic, which can easily be shared between different Dart apps. So a bit history, this architecture was introduced by Google at Google I/O 2019, and the current block architecture is the most popular Flutter architecture in the market. So we have architectures called Flex, but it's not that much popular as a blog because blog is more like easy to implement, and it has a wide support in the market, and blog is used by mostly with the guys whose background is mobile development. I mean, like with the guys who've been developing mobile apps for Android and iOS, and they switched to Flutter, and they prefer to use blog. And in terms of Flux, the web guys, the web developer guys like front end or back end, the guys who use mostly React, they prefer to use Flux. And it's like it's mostly a matter of preference, because the block and Flex, both of them do same thing: state management, managing the state of your application. As you know, yesterday Brad Morgan from Sydney talked that I agree with him, because it's a matter of preference. It's a matter of how your application is built, what do you need, and etc. So why we have to use block? So first, the advantage of the block is that know what state my application is at any point in time. For example, if you do some backend request like get the products or get the user, update the user, in that time you will know that that particular screen, for example, profile screen of your mobile application, will have the certain state, such as like loading state or get the result state, and etc. And the second advantage of the block is that easily test each case to make sure my app is responding appropriately. So because it's state management based architecture, so you know that in which state the error happened, right? So for example, if if you get some null pointer exception or class cast exception or some internet error, you will easily know in which state of your application. Is it in the state of loading, or is it in the state of getting the results from backend? And the third one is record every single user interaction in my application, so I can make data-driven decisions. So, for example, when the user interacts with your application, with your screen, when the user taps on button like update user or get the products or whatever, with this simple event, with this simple interaction, you will get the data, which is a data-driven, data-driven decisions. Sorry. And the another advantage on the block is that work as efficiently as possible and reuse components both within the application and across apps. So that's good, because in the block you separate your business logic apart from widget. For example, you have home screen widget, right, which extends from stateful or stateless widget, whatever, and you can just inject your block in that home screen, right, and then it's reusable. So with the home screen, you can use another, for example, profile block or different type of blocks, and which helps you to divide your application into some components like widgets and block components, and you can use some block. You can use you can use every block in every widget. In every widget you can use any block. So that's a good one. And the fifth one, I think, have many developers seem to be working with a single code base, following the same patterns and conventions. So what it means is that many developers are using it, and many developers are following the block pattern and the architecture, and it's easy to understand, it's easy to follow, and it's easy to make some changes. Develop fast and reactive apps because it's state management, and because it's already developed by good developers. I mean, the block is already implemented with some packages in Flutter, but you can also build your own block architecture by yourself from scratch. But we're going to talk about it later. So block built around three core values: simplicity, testability, and power. Simplicity means that every developer, when you deal with my code in a block architecture, you're gonna understand. Like we have like one screen, home screen, and we have home block, and we can easily make that interaction between home screen and home block easily, which makes simple for us to understand, and it's easy to implement, and you can see that simplicity. And testability, because every component is divided. Like every component is far from each other. They are not related to each other. You can use, for example, home block with the profile screen. You can use, for example, profile block with the home screen, and etc. Right? So that makes you do not depending your each block with some certain of components. So your each block is independent, and you can easily test your business logics within block. And of course, power, you can implement different types of applications with different types of complexity in a block architecture easily. How does block architecture work? So that's the interesting part. So this is a main diagram. You can find it on the internet. It's very popular. So basically, we have here stream builder inside the widget. So let's do like this so you can understand. So we have stream builder with the widget. So this is our block component. When I say component, I say just class. We have like block class, and the communication between the block component, block class, and the widget. When I say widget, it's like one screen. One screen will be through stream data. So for example, when the user clicks on some button, it will send that is an event, as an event. We're gonna talk about it later. To block, and the block will process that event and returns the result to widget. So that's it. So here we have like block provider. What it does is that block provider, from its name you can understand that block provider provides block component to widget. Understand? So block provider is inherited from is a subclass of inherited widget. So we in the code we mostly deal with these three components: block provider and widget and block component. So stream builder, what it does is that widget will communicate with the stream builders, and stream builder communicates with block component. So that's it. That's the whole architecture. For example, inside the widget, inside your screen, when you click the button, you're gonna send that click of event. We call in block event to block component. Block component, for example, gonna do its process like get the data from internet or save data to local storage or whatever, and returns that result to your widget, and widget can show the success screen or can show the fail screen, can show product, and etc. So with the block provider only provides one time like block component to widget, and that's it. So that's the job of the block provider. And let's talk about the concepts of block, and like in terms we're going to use what type of things we're going to use in block architecture. So we have three components, but the stream is not component, but I added as a component because you have to understand it. So we have like 4 components: events, and states, a block component, and stream. So what's events? Events is like actions of the user. For example, user tap on button, or user type in the edit text, or user swipe refresh to layout, or user scroll, or whatever action happens with the user and the screen of your phone is called events. And so in the term we can say that events and actions are the inputs of the block architecture. For example, you're going to tap on the button and it will go as input to block architecture. And they are commonly created in response to user interaction with the interface, such as button press or lifecycle events like page loads and etc. As I said, that button press, edit text type, or scroll up, scroll down, or screen change, and etc. When designing an app, we need to step back and define how users will interact with it. So yeah, that's correct. That's the main part. You have to understand, you have to define every time when you try to create a new screen, you have to make sure that what type of interaction will have that screen with the user. For example, I have profile screen, right? And in that profile screen, I have to define like I'm gonna have like 4 edit text for first name, last name, gender, and birthday, and I'm gonna have save button. So that means I'm going to have one event and the 4 fields. So when the user press that event, which is save button, it will take that 4 data, first name, last name, birthday, and gender, and send it to a block component. So don't forget that every time when you design each screen, you have to write down what type of events that screen will have. States are the outputs of the block architecture. That's correct. For example, when you send the event to block architecture, block architecture will process that input. For example, when you say to block architecture, hey, get me a list of products for this user, right? And block architecture will go to backend, will go through internet, and get the list of products and the filter set product and returns it to block, and block returns the widget to UI to the user in a form of state. State is a simple class, simple class, and inside of that state we're gonna have our data. So we just simply wrap our list of data to state class. And the 0 represent part of your app's common state, right? For example, each screen will have different type of states, right? For example, loading state when showing the progress, when showing list of products is also state, and when showing the fail is also state. UI components can be notified of the states and redraw portions of themselves based on the current state. So when the widgets receive new state, they will redraw themselves. They will, because for example, when you receive fail, before fail, we're gonna have like progress state, right? So they have to remove that progress state and redraw from 0 from scratch result state or fail state. A block is a main component. Component. When we say block component, business logic component, we say just simple class. Just for example, a profile block, a home block, main block, edit user block, whatever. And the main idea, main responsibility of the block is that it's going to receive some input, some event from the user. As I said before, button tap or scroll or load, whatever, and process that input and returns as a state of this input to widget. That's it. That's a simple part of the block. Here it says that think of block as a brain that receives information, processes it, and provides a response. Yeah, it received the input as the event, and it processes that input, like getting data from internet or getting data from database, and filters it, process it, map it to object, wherever, and returns that response to widget. A stream. A stream is a sequence of asynchronous data. So basically, when we add some event to block, it will be added to stream. Stream, how to say? Stream is a list of events. It's like queue, and it will receive inputs in the queue, and it will process each data in the queue. And in returns also in terms of stream. Stream is a sequence of asynchronous data. That's it. A sequence of events, sequence of states. Best way to use block architecture. So you can implement block architecture. You can implement the block architecture in two ways. The first one, you can create it from scratch. So for example, you can create all that things like events, blocks, streams, and etc. by yourself. No one will punish you for that. And the second one is user-ready solutions. So the Flutter was founded in 2017, and it was more than 2.5 years. And there are dozens of solutions of the block architecture. Before most of the senior developers, leads already implemented good ready solutions to your every business need. So what I'm saying is that it's like not working. There were some technical problems. So yeah, don't create scratch. So don't reinvent the wheel, because already we have dozens of packages for Flutter block. So problem with using your own solution, as I said, is that if you develop your Flutter apps architecture from scratch, you will need to create custom code and streams. This takes time, of course, and in the long run can lead to boilerplate or spaghetti code. For example, you will rewrite each time like some certain certain amount of code in every place of your project. That's a boilerplate, so it's not the follow of the clean architecture, yeah, and then also it will lead to hard to maintain your application. That's why I suggest you to use ready solutions. For example, Google's block library is one of the best solutions, one of the best packages out there. You can use it, and it has a lot of issues which were fixed by Google developers in the GitHub. So that's good. So I suggest you to use block architecture. It's my just suggestion. It's my just opinion, and you can just create it from scratch, but you have to be ready that in the future you're gonna have to deal with spaghetti code, boilerplate code, and it will lead you to some problems which is hard to maintain your application in the future. So that's it. So, and it was like more theoretical way of explaining to you the block architecture. So let's write some code. So yesterday I created some simple project for you to understand block architecture and how to use, how to implement. So I created a simple app. What it does is, so we have 1, 2, 3, 4, 5, 6 models. I'm going to divide that models into packages. Let's create some package called block, and I'm going to put there all the blocks in my application. And I'm going to create a UI block. So UI is my widgets, my screens, right? Yeah, we divided my project into some called modules, packages. So block contains block component of my screens. UI contains only screens and some custom progress, whatever. Yeah, just progress. So yeah. So my application is simple. I'm going to have one screen, list of products, and in another screen, we will have detail of the product. So let's go to my product list screen and open product list block. As you see, product list block, sorry. So this is my block. Sorry, this is my screen. Product list screen. This is my block. That's it. This is how block component should look like. It's like 40 lines of code, and that's it. So you're gonna create your block component by extending the block class, and in a sub in a generic types, you have to implement two things. First, event of the user. As I said, for example, in the product list screen, I will show you how we're going to create event, and the product list state. So this is the product list block. We will have two, and we'll have one event, and sorry, we will have two things in the block. The first is event, and second is state. So product list event, you can name whatever you want based on your screen, based on your preference. I prefer like in this way. In a product list state, we will wrap that input and process that and return as a list. For example, and we have to override two methods. So sorry, before showing that, I have to show one thing. I forgot it. So we are using Google's Flutter block architecture. So I'm not creating by scratch. I'm using existing solution because it's already fixed. It's already working stable, and most of the developers are using it. So I also suggest you to use it. So Flutter block. So these all are these all blocks, events, class, override methods, and etc. are from coming from Flutter block package. So what I did is that map to event state. So when your product list block is created inside your screen, here you can see we are creating the product list block. So I'm gonna tell you how that block is created in detail later. So when you create it, that method initial state will be called, and that product list init state will be returned to product list screen. And then map to event state, when it will be called, when the user do some input to your screen. For example, when the user press save button, or when the user enters to screen, and it will be called get the products, you know. So in that case, these events will be called with the event which is received from the screen. For example, if the event is get product list event, then we're gonna yield. Yield is a Dart keyword which will add your asynchronous data to stream and returns it. And the and we first show the user loading state. And just for demonstration purposes, like here should be, for example, get data from internet, right? Let's call it from API, right? So I just from internet call it will take some time. So that's why I just put here delay. And after receiving the result, we process that result, and after that, I'm hiding that loader. And after hiding that loader, I'm showing data with the state. So I'm just wrapping data inside my product result state. So from where I'm getting these classes like product listing state or loading state or whatever, I just define it here in my block components. For example, I'm going to have base product list state, and all my states will extend it, right? For example, loading state also extend product list state, right? So it's just classes. If you have to show the result to user, then you can wrap your state with the objects. This is a state which process your block and returns to user, and this is the events which user will add it. I mean, which user will input it. So if for example, you can also add some events here. For example, save product event, right? And here you can just add name, product price, right? Etc. So this means we are getting the results, we are getting the user input in the form of event and returns it here. And when the user enters add product event, we can just show yield new loading state. Process it, data get, save data, API, and with the result we can show hide loading state. Etc. So basically that's it. So this is how we can say the product. And so this is a block component. That's it. That's it for Flutter block. That's it for block architecture. So this is the main part. So we're gonna talk about other parts in a minute. So this was the main part of our presentation. So hope you understand it. So just to wrap up, you have to create your class, you have to create your blog component and extend it with a blog with the event and states, and you have to define your event and states inside your blog file or whatever you prefer, and you can use that states with your mapped event state. So mapped event means that we will process the event and returns states based on event. So this is the processing. This is it. And after that, yeah, that's it. And we can go to our screen. As you know, I just created stateful widget, and I'm dealing with states. So I'm just defining my product list block, which is here, and then this is just progress to show. And I'm getting the block component. I'm initializing my block component. This is one way to initialize. In the internet, you can find different type of ways to implement your block. And why we use that, because you can also use the product list block. It's no problem. But we use here the provider component, which we provide provide product list screen from main.file. As you can see, we used block provider, which provides product list, all of the existing, all of the defined product list block. And so after that, we define our event. So when the user opens that screen, we call the event get products event. So that means that we adding the event to stream, and from stream we process it and returns the result to user. Here our widget, builder, our build class, our build method. In builder, we as you can see, so how to say, we have block consumer. Block consumer wraps our widget, wraps our, for example, here you can see our scaffold, right? It wraps it, and that helps us to connect our widget to our block. So in this block consumer, in this way, we can listen our all states from block, and we can redraw our class, our widget based on state. So for example, if there is a data, you're gonna show the result. If there is no, you don't show the results, right? So that's it. So we have block consumer. We have two listeners, two methods. First is listener method and builder method. Builder method draws our views, our widgets. Sorry. And then we have listener state, which will not return anything. It's just for the purpose to show the progress. So you cannot show the progress here because it returns a widget. That's why Flutter block provides a listener method, which do not need to return anything. You just do void methods calls. For example, show progress, hide progress, show toast, hide toast, show log, or whatever. So that's it. And that's it for product list screen. Let's go to let's do what? Let's implement our product detail block and product detail screen. So in order to do that, as you can see, we implemented product detail So before implementing that, let's run our code. I was having some problems with running my code in emulator. Oh, it's running good. Let's wait a couple of minutes to start it. Sorry, it's taking a bit longer than I expect. Uh, that's weird. It doesn't have to take that much. So finally, yeah, I was able to run it. I mean, open the emulator. Let's run it. Because I'm streaming and I'm also opening Android Studio, opening emulator, and that's why it's kind of lagging. Sorry about that. So until loading that, I'll go through my code again just to make sure that you understand. So first, what we did is that we provide our product list block to our product list screen. In that way, we connect our block with the product list screen and we define the stream. So when we add the event inside product list screen, here it will be added to stream, and streams will be sent to product product list block. So second, after defining our block, we are adding event here. Block inside block, we are adding events, which is user input. And here we are receiving that input and processing that input based on the event type. For if it's get product event, processed in this way. If it's a save product event, processed in this way, and etc. Yeah, after doing that, when we call this yield keyword from block, it means that we are adding our state to stream, and the stream of data will be sent to these two methods, builder and listener class, listener methods here. And listener is a non-return type. I mean, void method, which we can do a void type of method calls, such as show progress, hide progress. In terms of builder, in the builder method, you have to return widget itself. So that's why you cannot call here void type of method calls. So that's it. So what happened? Installing. Oh yay, it's installing. So as you can see, yeah. So as you saw that there was shown first progress, and then the product list, and then the progress was hidden. If you click here, progress was shown for 2 seconds, and then yeah, and then show the product, because here we said that first show the loading state, which is progress, and then hide the progress, and then show the results. So that was done in the widget itself. So here, if the state is loading state, then it will show the progress. It's just dialog which I created. And then if it's the state is hide loader state, then it will hide our dialog. And there are different ways of creating the blocks in Flutter block. You can use, I use most of the time block consumer, because I need to use listener for logging, listener for showing progress, and etc. So that's it. So I think we have time to implement detail. For example, if you click on the product, it's showing the detail of the project, right? So yeah, this is one block with one screen, one block. This is another screen, another block. Let's try to implement that. If event is product event, which means the detail of the product, we use yeah, we have to write down here async method, yield new. For example, let's do some loader also here. It's extending from product state class hide loader state. It's also extending from product state. So why we have to extend it from product state? Because we use product state as our main blocks part. So if you use here only hide loader, you cannot use here states, right? So that's a general one. So you can use different type. You can return different type of states based on product state. Sorry. We use a loader. Get the data, get detail of product, and process it and yield the new hide loader state. We can also create product detail state. Product detail result state, let's call it. I have some problems with naming. Yield new product detail result state, and let's add here the string name of the product. You can see we have to initialize our product detail. Are you okay? Let's see its product list. Why it's showing error? Because we didn't import the package. So let's import the package here. It's Flutter block. So it's working, and then we have to implement that consumer. And like it here. Product detail block, product state. Yeah, that's it. We implemented our and we can show the product detail, not in detail, but instead detail we can show name. We can get a name, for example, string name. Let's do it empty. The state is product detail result, and you can get the product name from states. We can just show that name here. Right? So that's it. And just need to add event. to process our input, and product event, which means getting the product event here. I didn't put here any I'll say any delays. So it's saying there's a problem with hide loading. We'll just hide loading state. All right, so while building it, let's stop my presentation here because I have left like 8 minutes. So let's do some Q&As. If you have guys any questions, I'm glad to answer them.
So, of course, we have some questions.
Yeah, well, thanks for your presentation. There are several questions. Well, I think one of them is pretty important. This one.
How are you?
Yeah.
Thank you very much. I'm doing great.
Okay.
So yeah. Oh.
So.
All right. Which one is better, native or cross? What's the future of Flutter? So this is this is kind of hard question to answer because each platform, each path has its own future. For example, native will never die, and cross-platform will also never die because they have different type of feature, different type of stacks. So Flutter, the cross-platform development, is mostly used for with the startups in order to bring the MVP of the product within short period of time. Because with the Flutter, as you know, you can do for two platforms, right? With the native, you have to spend resources and you have to spend time for each platform. For example, you can do one application for 1 month. With 1 month in native development, you can do only one application for Android or for iOS. So I would say it's not which is better. I would say that it depends on your business need. It depends on your preference. I would say if your business needs that to ship the product within short period of time with the both platform, then you have to use definitely Flutter or React Native. If you're a big company, if you are using mostly native APIs such as for example, using the camera of your phone or using the Bluetooth or using some location services, I would say to use native because Flutter is not that much mature to implement in a smooth way these low level APIs.
So it's basically just a set of tools, and you cannot say that hammer is better than a screwdriver. They just have a different usage.
Yes, correct.
Okay. And what can you tell about other popular patterns that can be used other than block? Because we've heard a lot about them like before, in both web development and mobile development.
So other than block, we have MVI, MVVM, but it's hard to implement that type of architecture in Flutter because Flutter is different. I mean, different concept. Flutter use state management, like similar to React. So it's hard to implement MVI and MVVM architecture, but we have that architectures. And another popular architecture with the block is a Flux. As I said, it's mostly it's very similar with each other, but with the difference that they use instead of block component they use other component to handle events and states, and it's similar to React's Redux architecture. As you know, in React we have like Redux pattern, Redux architecture, which handles state management, and it's similar to Redux architecture in Flux. So we have like Flux, AVI, VM, and if I'm not mistaken, there is also Flutter Redux or something out there, but I have never used that.
And in case we are using, we are creating a new application that is like 2 or 3 screens big, in what cases we should consider using block, and in what cases we shouldn't?
So in case that if your application have more than, let's say, 10 business logics, I mean, saying when I say 10 business logic, I say 10 screen basically. For example, you have home screen, product screen, profile screen, etc. If it's more than 10, you have to try to use block architecture because that much of that type of business logics is considered in a programming big, because 10 business logic is big, so that's why it has most probable that some of your business logic could be reused. So if you do some block architecture, as I said, block architecture will divide your components with each other, and so it will not allow you to connect your components with the widgets or screens. So you can use your some of your widgets, some of your blocks, which is business logics, with other screens. So I would say, so if you have like more than 10 screen, more than 10 business logics, then use the block. If it's less than 10, then you can use just simple Flutter state managements. So you don't have to import or implement any blocks. So you can use just you can just create some data manager class globally, and you can use that data manager class globally in all your widgets, in all your screens.
Okay, thank you. And how would you compare it to provider using like more traditional providers?
Provider and block make the same thing, the difference between their functionality. So as I said, block is a component which receives the input and processes it and returns state to widget, and provider provides that block component to your widget, to your screen, and connects your block and the screen widget with the stream the communication mean between widget and the block component.
Okay, well, thank you very much for your tutorial. I hope it would be really helpful for those who are now looking into Flutter and exploring the possibilities it could provide, especially in the field. Just our viewers, please don't forget that those are tools. You have to understand in which case which tools are applicable. Now, we wish you have a good day. Thank you.
Yeah, thank you very much. Hope to see you in the next events.
And now we are welcoming our next speaker, Mr. Victor Sanchez.
Hi.
I'm
Victor,
sorry,
we
we
don't
have
hear you.
problems with the microphone.
Victor, we still didn't hear you.
Well, we are experiencing a little bit of technical issues. Stay with us.
He will come after 1 minute, say.
Can you hear me now? 1, 2, 1, 2.
Yep. Great.
All right, that's better. Sorry about that. How are you? Thank you very much for having me. Good morning.
Great. Thanks. Thank you for joining. So now we are going to talk about web development, right? And web components.
Correct. That's correct.
So I'm giving you the stream. Have a good day.
Absolutely. Thank you very much. Perfect. Then I'm going to show you my screen, guys, and let's get started. Wonderful. I believe everyone can see me. That's perfect. Let me do a little bit of composing over here. I had everything ready, but of course I had to reload because of my microphone, so sorry about that. All right, so the title of my talk is Getting Started with Web Components. What we're gonna be doing today is learning a little bit about what are web components, how can we make them very, very easy. In fact, we're gonna be making together our first web components and understanding what are the advantages of all of those. And then we will learn a little bit on how to learn more by ourselves. My name is Victor Sanchez. I am the CEO for Syncrtes Incorporated, which is a company that does web video conferencing for education, especially important nowadays with the coronavirus pandemic. But one of the things that we do, or basically the mostly of the things that we do, is everything that we do is a website. Everything that we do is a web application. And we use web components ourselves for absolutely everything, for smaller devices to very large video walls where we do video conferencing. Absolutely all of our products are made with web components. I am also a Google developer expert in web technologies. And yeah, I'm super excited to be here. I was mentioning the other day in Twitter, one of the great advantages of this year is that the DevFest is more international than ever, right? Usually I wouldn't have been able to fly to see you to one of these events. So being able to connect and be here with you, it's really exciting for me. So let's take a look and let's get started. So the first thing that we need to understand is what are web components, and most importantly, why do they matter? And this is for me something that we should ask ourselves in every single technology, right? It's not only, oh, let's use the latest, coolest framework or the latest, coolest standard or the latest, coolest whatever. Why are we using that? Then I'm going to be speaking about two things that Google made out of the Polymer project and that right now are massively important and massively successful open source projects, which are Lead Element and Lead HTML. I will talk to you also a little bit about the story of web components, how Google was very influential into making them. And of course, it wasn't only Google, right? There are many other collaborators on that, but I will explain you a little bit on that. And of course, we will make an example. I call it Instacat because you cannot have an online talk over the internet without dealing with cats. So of course, my example had to be cat related in some way. And at the very end, I will show you how to learn more on yourself, right? And every developer uses Google or any other type of search to keep learning. I did it when I was younger, right? I did it every day as part of my job. And learning how to keep learning is also extremely important for a developer. So I'm going to be also commenting onto that in a little bit. Before we started, what are web components and why do they matter? So let me first kind of go way, way, way back, like 29 years back correctly. So 29 years back, the World Wide Web was looking very, very different. That is a screenshot, a simulated screenshot, because no one actually took a picture in 1991 for that first website. It was like, I believe this screenshot is from 1983 or something like that. But that is on your left, the very first website ever created. And as you can see, it's quite a simple one, right? We have like a header with a title, probably an H1 or an H2. We have some text, some links, some blue links, nothing fancy, right? Just a couple of list links that link probably to other websites that were created together with this one on that page. Now, let's travel 29 years to the future, to yesterday, with my slides on Google Docs in 2020. That's also a website, right? And look at that. It has changed so very much. It's insane, the number of things that we are able to do right now inside the web browser. At the beginning, right, the HTML was designed as a very simple markup language to be able to structure some information and link it to other HTML pages that were online. We had two very different walls. We had our installed applications, right? Microsoft Word or maybe Lotus Notes years back, right? We had our installed applications where functionality was expected. And then we have the internet. The internet was basically linked documents that we could jump to and find information on those pieces. But what happened? Over the years, over 29 years, little by little, the web decided that that wasn't enough for it, right? We wanted more. And what we did was making the web more and more functional. If you remember, right, if you go back, the first things that we saw that made the web a little bit more interactive were, of course, the server-side languages, right? We have things like PHP, we have things like Python, Perl, many others that started to give us the ability to make the websites kinda interactive. So if you had like a PHP page and you could actually go page 1, page 2 as an attribute on the URL, that website seemed to be having pages, right? That we were coming back and forth. Maybe you could change the language of some of those websites, and that seemed kind of interactive. Then, a couple of years, it wasn't actually that far, Ajax came, right? The ability to do asynchronous request inside the web application, basically changing a piece of your website in real time. And we tricked the users, basically telling them, this website is interactive. It was not, right? We just were making another request to the server and repainting a piece of our website. And again, for a little bit of time, we actually thought, oh, that may be an interactive website, but things went further and further away. And at the end of that very long 29-year trip, we ended up with websites that are as interactive as any of our installed applications, websites that have nothing to envy to what we have. We have Angry Birds on the web. We have Unity games on the web, thanks to WebGL. We have full document sets that have nothing to envy to Microsoft Office, right? Have Google Docs, we have Office Online even. So all of those things have basically become a new operative system full of applications inside our web browser. So what happened? Our languages, the languages that we originally had, HTML, CSS, and JavaScript, were designed to do much simpler things. And now, 9 years later, web developers are asked to do way more, right? Interactive applications. So, of course, the languages needed to evolve, and they did. HTML5, CSS3, JavaScript have evolved massively over the years. But even with that, it wasn't enough. And the latest evolution on how to write your website, on how to make your websites functional and quick and interactive and interoperable are web components. So let's take a look at the modern website, right? Any modern website would look like the graphic that I have on my right. We have a header that has a title, that has a subtitle. We have a menu with a list of things, an article with a ton of things inside. We have our list, our sidebar, our images, paragraph sections, footers, full of links that at the same time have lists. It's massively complex. And I'm sure that all of you are familiar with the box model, right? This, I open a div, inside the div, inside the div, inside the div, and that is an absolute mess. HTML5 provided something else called the semantic model, which is basically, let's call things and let's make tags that are designed to make your code readable, right? And one of the most important things as a developer is always the same, is make your code understandable for each other, but most importantly, make your code understandable for you. If I go back, I've been doing websites since I was like 9 years old. If I go back to my first websites, right, I wouldn't be able to read my code. But the sad thing is, even as a professional developer, if I go back to, I don't know, a 5-year-old website that I made, I probably will still struggle about having that. So readability, right, the ability to understand your own code matters a lot. I mean, it's probably the thing that matters the most, if you ask me, in terms of that. Your code is efficient, that's great. Your code is not readable, that's a mess. You are in hell of a trouble if you are trying to do that. So you need more, right, in order to have that capability. So if the box model is not enough, if the semantic approach that HTML5 brought us with tags like header, article, footer, which were much more descriptive of the content, what do we do? In any language, literally in any language, you have the ability to name your own stuff, right? In Java, you can make your own classes and talk to the class about my bottle.java, right? You can make your own things. In HTML, you were given a bag of tags, right? P for paragraphs, EMG for images, body for the body of the website. You were given this bag of predefined things, and you were asked to build the Eiffel Tower with a very limited set of pieces. That's not fair. So web components to the rescue. I love this slide, I'm sorry. I'm an idiot. So what are web components? Web components allow us to create custom, reusable, encapsulated, and interoperable HTML tags. So this slide is the typical slide that, you know, your 70-year-old teacher will put at the university, and you will understand absolutely nothing. So let's break it up into pieces. By the way, I'm going to be using colors during the presentation to guide you on where to look, especially when I'm sharing code. So I'm going to do the same here. I have selected in several colors the important words of this very convoluted sentence: custom, reusable, encapsulated, and interoperable. Let's take a look at what each of these words are going to mean. First of all, custom. Custom is what I told you before. If I want to create in my website a bottle, right? If I want to do that, why do I need to open a div ID equals my bottle and then define that inside? Why I cannot create my own tag, my bottle, and be able to create a tag in a custom way as I do in any other language? So that's the first thing that web components are going to allow us to do. Create our very own HTML tags. Forget about that limited bag of pieces. Now I can create my own pieces and combine it, of course, with all the tags, right, that I already had on my HTML bag of tricks. But now I can create way more. Not only that, those tags that I create can be reused by me, by my team or by other developers. And therefore, I can also take out of other developers different tags and use them on that part. That's really, really exciting. Encapsulated. This is a concept that is super important. How many of you have used jQuery in the past, right? JavaScript query, jQuery. It became probably the most famous library for web developers in the world, not that long ago. And I'm sure that you remember things like, I open jQuery, I open the brackets, and then inside there, I put 800 lines of code, 1,800 lines of code. All my JavaScript code in a long 1,000 line mess, right? That was the jQuery way. And again, I have many websites that I did that look exactly like that. So I am guilty as hell, as probably most of you that have been developing web for some years are too. So the concept of encapsulation, it's really important, right? It comes with many others around. If you had like a word tag, right, of what encapsulation means, and you look around it, you will see things like sharing responsibilities, right? Like classes, like how to divide your code properly so it's understandable. So basically, one of the things that web components will allow us is to separate our HTML tags, the ones that we create for ourselves, and its behavior, its styles, its representation, its interactions are going to be separated, right? Encapsulated on its own files, on its own data structure. So we are, again, organizing, reading our code better, making it more secure. Finally, interoperability. It doesn't matter if I can create my own pieces, if I cannot tell you, if I cannot give you that piece and interoperate it with your own pieces, whether those pieces are created with what we call vanilla web components, so basically only using the standards. If you are using something like a little bit of help, like lit element or lit HTML to create elements and templates respectively, or something more complicated, like the earlier versions of Polymer or React or Angular or whatever it is that you are using to create your components. You want your components to be interoperable, right? You want to be able to mix on the same website a component created in React, a component created in Vue, a component created in Polymer, or a component created with Lit, all in the same way, right? And you want that to work across browsers, right? In every single browser, or at least in every single modern browser that you can actually get there. So that's what web components are all about: custom, reusable, encapsulated, and interoperable HTML tags. Why? Because of readability. So I have an example, right? An example is not that hard, where I want to list a cat list, right? Elements with cats. So I have my article, I have my header, Instacat, I have my section of class cat that has some styles, that inside has a paragraph that is the cat name that is called Simba. And then I have my image for that cat, and then I close the section and I open another one and I do exactly the same. So that is before web components, right? And that's how the websites look. I wrote this a couple of days ago and I'm having trouble reading it now. Look at the right. Look at how web components will allow us to do. Did the Instacat tag, HTML tag, existed yesterday? Probably not. You have to be an idiot like me to create it. Did the cat card element, HTML tag, existed before with an attribute called name that you can put names like Simba and Milo in order to create cats? Probably not. You have to be an idiot to create them, but I did. Now they do. Now they exist. I could share it with you and you could use it on your websites. And now you have a way to list cats and have individual cats in their own card. So I created, right, my own tags. And this looks like magic on HTML. But again, if you go to any other language, this is nothing new. You should be able to create your own stuff, right? It was artificial before, the HTML limited bag of tags. It was an artificial way to do this, right? Why we couldn't create this from the very beginning? I don't know. Now we can. So what are the standards that are behind the whole structure of how web component or work. So the first one is custom elements. Is a way, an HTML plus JavaScript way to define, right, these new custom elements, to register to the browser and tell them, hey, when I create the tag my cat or cat card or Instacat, this is not something that you don't understand anymore, browser. From now on, when I give you this name of a tag, you need to interpret it using my code. So custom elements basically allow you to do that. Is, hey, browser, here is a new tag that I created, and now you're going to help me paint it. The second one is templates. Templates are the ability, right, to tell you, this custom element has this structure. A cat card is a name of the cat, an image of the cat, and a button to delete it, for instance. So templates allow you to define new templates and tell the browser, not only you are going to understand the cat card tag, you are also going to know that when you see this tag, you want to paint this template. The other one is shadow DOM. This is really important. I'm sure that most of you are familiar with the DOM, right? Basically, the DOM is the structure, right? The document, the structure of an HTML page is this tree of tags from body. Inside the body, I have a div. Inside the div, I have a paragraph. Inside the paragraph, I have whatever, right? So that structure of trees of connected nodes is called the DOM. In web components, we're going to be creating something called the shadow DOM. And the shadow DOM is basically a DOM inside the DOM. And that is really important because when I have a regular website, right, one of the other ones that I showed you very messy with a lot of tags, there is a couple of very important things over there. The first one is that when I want to find the tag, right, with my CSS selectors or with my JavaScript document find by ID or whatever I want to do it, right, querying the DOM in some way. And I do that all the time because now my websites are interactive. They are web apps, right? So if I'm doing all of that, I'm going to need to, if I want to search something inside that DOM, to modify it, to style it in any way, I'm going to have to look from the top of the tree and go all the way down through that tree for all the options, every single branch, trying to find the right thing to modify. That is a mess, and it's really inefficient. It's really slow. It makes web applications almost impossible, right? Even though we have been battling with that for years, but it makes it so hard, unnecessarily hard. With Shadow DOM, though, we can change that completely. Shadow DOM is the idea of when a web component is pasted, right, is on your DOM, we will create a Shadow DOM inside. Therefore, if you are looking something inside your component, instead of starting at the very top of the tree, we are going to be starting at the very start of your web component. So you don't look the whole website trying to style something. You don't look the whole website trying to do some code. What you do is you start inside your own web component. That start of the web component is going to be called the shadow root. Basically, the root of that new tree that has a parallel dimension with all my code inside that element. That makes websites way faster, a lot faster. Finally, there was a fourth standard, and it was called HTML imports, but that one I crossed because it's not the standard anymore. Actually, it never became one. There was kind of a small fight, as there in good standards should be, about which ones do we take or not take, and HTML imports never made it. The reason why is because HTML import was invented at the same time that ECMAScript 6 and it was ramping up. What happened is that ECMAScript modules and the ability to import JavaScript modules really quickly became more powerful, more accepted, more standard than HTML imports ever was. So basically, the way that we import this, and this is really important, and is if I have a website and I have encapsulated code in different files, how do I make them talk to each other? So before it was HTML import, when I started with web components, now is ECMAScript modules. All right, you made it this far, 25 minutes in. We are ready to put some code together. But first, 2 more slides with dense things. Lit element. What is lit element? Lit element is the grandson of Polymer. Polymer was a project, right, that Google started to create web components. And I remember the Google I/O event when I was there in San Francisco, and they told us the objective of Polymer is to disappear. Why? Because we want the web components standard to become part of the browser. In the meantime, Polymer as a framework is going to help you. Polymer 1, well, Polymer 0, 1, 0, 2, Polymer 1, 2, and 3. They were getting smaller. They were doing less things instead of more because the browser was able to do more and more and more. Lit element is the smallest piece ever of web component sugar, if you want, that Google is adding, and now again, open source project on that. So it's a super simple and very, very lightweight base class to create web components. So, and again, I'm sure the objective of lit element is also to disappear, right? It's also that eventually this is going to be part of every single browser as that. In the meantime, we are using lit element to make our ability to create components a little bit easier than it would be with vanilla web components. When I say vanilla, again, I refer to the kind of default 4 APIs that I just was speaking about a moment ago. This is, by the way, absolutely interoperable. Also, you are going to be seeing, let me put the pointer one moment. In many of my slides, you will be seeing this. Okay, let's see if the menu disappears. Mr. Menu, go away. No. Okay, so in here, on the bottom of my slides, you will be seeing a lot of links. So I'm going to be putting for you a lot of links on when this information is coming from, right? And some of them are shameless copy-pasted definitions, shameless copy-pasted pieces of the API, because again, there is no shame in Googling when you need information. So I'm going to tell you, where do I get all of this information? How did I learn myself to do all of this? Lit HTML. Lit HTML is the other side of Lit, and is the part of the template. It's the ability to write basically HTML templates inside JavaScript files. And the most important about Lit HTML, once more, right? The words with different color. It's reusable, it's quick, and it's efficient. It's quick to render, I'm saying here, and efficient to re-render. This is really important. Let's say that you have a massive website, right? And a change that I do inside that website changes only one word of the whole document. And on that one word, I decide, oh, that's really important. I'm going to have to re-render the whole page to change one word. Lit HTML doesn't do that. They are able, with Lit HTML, we are going to be able to only re-render the piece in there that we need to change, keeping everything else intact. There is a lot of ways to do this. One of them is what's called the virtual DOM, making differentials with DOMs. There is a lot of inefficient way to do this, is what I'm saying. Lit HTML, it's famous for its efficiency on re-rendering, and that helps also on how quick it is to render. All right, let's create Instacat. So the Instacat example couldn't be more silly. It's the web app that we are seeing on that. It's very, very ugly, but the cats are very, very cute. So I hope that one compensated the other. But basically, we're going to have a form where I can put a name of a cute cat. I'm going to click on a button, and it will create a new element with the name of the cat, a picture of a random cat, and a button to delete it in case that I don't like that cat, if that's even possible. I'm gonna try to do that, right? Or my objective when I created this example was to do this in 100 lines of code or less. In the end, I believe I have like 117 lines or something like that. But my point here was I wanted to make the code very readable, very understandable, and as small as humanly possible in terms of the space. But I didn't do any kind of tricks of removing spaces or removing empty lines that I believe it was important. But you will see that the code is very readable, right? Very easy to understand. And we are able to do quite a bit of functionality, actually, right? We are having different elements, the list itself, the cats on a different way. We are able to add them. We are able to remove one of them, some of them, all of them, in a very dynamic and very fast way, thanks to Lit HTML and Lit element. So let's take a look and let's get started. You make it this far, I promise the second half going to be a little bit simpler. Maybe not. I start with a simple HTML document. So if you are following this, probably you're going to be seeing the recording in YouTube later, right? So stop, create your typical HTML5 a structure, doc type, HTML, body, a header, and close your tags. Now, let's create our very first lit element. So here, once more, we go to the importance, right, of having this. So we're going to do the same, right? We're going to put the H1 Instacat, but instead of doing it with 5 lines, now I did it with 25. So far, I get a thumbs down on efficiency. I know that, but believe me, it's going to be worth it. So the first thing is line number 4. I created, I don't know still how, right? It's covered the rest of your screen, but I created the first Instacat tag, right? I put an Instacat and we wrote something. In this case, only an H1 saying the title. But hey, we did something over there. Look at what comes next. At the beginning of line 6, we are creating a script tag with type module, right? The first line, really important, it's an import, right? An ECMAScript 6 import. We are importing lit element and HTML, which are, again, lit element and lit HTML, what we just said, from the unpackage.com/lit element module. And now look at this. All of our web components are going to be ECMAScript 6 classes. So we create class Instacat, extends lit element, and I'm going to create 2 things for the time being. The first one, the connected callback, which is going to call to the super.connected callback that is on the green area once more, line 11. This is basically from my parent class. When I do super, I call to the parent class. So I go to the lit element class and I tell you to do everything that you would do regularly on the connected callback, dear dad, right? My class on top. Do it anyway. And also do a console log hello world, which we can see on the screenshot that I took on the right with that very proud little dog. Also, on the render, we are going to use our very first HTML generated, JavaScript generated in this case, with lit HTML. And this one is very, very, very easy. But look at that. We are, this is a very weird expression, right? We have HTML, very important on line 16. I am opening, this is not a regular tick, this is not a regular apostrophe, this is a back tick, right? It's a template, it's a literal in JavaScript. It's really important that you get used to use backticks in every template from lit HTML, whether it is HTML or CSS, you're going to be using backticks. So we told them there is another method that we inherit from lit element, which is render, and we tell them what to render. In this case, is an HTML template that says H1 Instacat close H1. And look at the very end, line 22 in blue. Custom elements define Instacat and then the name of the class Instacat. So we tell them how the tag looks like. Usually by convention we use dash, second name, dash, whatever it is. So if I do my bottle, I would do my dash bottle, right? But the classes, we name them as you would do on any language, right? With the upper and lower cases in this way, Instacat. So if we run that in our browser, right, there is nothing to do. We open this, we save this HTML file, we open it, and what we get is the Instacat hello world. We have the hello world on the console, the Instacat on the render side. Great. I hope you are following me. If not, feel free to ask me questions when we finish on this. Second thing, let's make it a little bit more complicated. So I added 2 lines now. Line number 9, where I define a constant called app title, and then I call it Instacat. And look at line 19. Have H1 $symbol, I open keys and close keys, app title. So basically what I'm telling is, hey, inside this template, I want you to render something else, right? Instead that a special $tag, you're going to take my constant or my variable or the result of a function, and you're going to create it over there. So that's what we call a binding, a lit HTML binding. Copy pasted directly from the URL that you have on the bottom. Here is a couple of things that I can do. I can do it with text, with attributes, with Boolean attributes, with properties, or even with event listeners. So I don't want you to kind of go through this content right now, but I want you to know that there is a lot that you can put inside a template, right? That's my point. And it's impossible for me to teach you all in the 1 hour that we have together today. But definitely, I have used the first example, right? The one that says text binding, hello, daughter name, right? But we could have done this as an attribute, right? With the ID, for instance. Look at how they use the Boolean, right? And in a checkbox, true or false. The value inside an input, for instance. And then we're going to be looking later at how some of those events work. Do I know this by heart? Most of them I do, because I have used LitElement for a while now, but you shouldn't, right? I was having this website open, I don't know, my first 2 months coding with LitElement. I had the documentation open. There is no shame on that. Make sure that you have your references right. That's really important, right? That you check references and no, fake news, but make sure that you look at what you should. Okay, let's do a little bit more. So the next thing that we're going to do inside our Instacat element is use 2 other things. The first one is the properties, and the second one, the constructor of the class. So properties, in this case, I want to have 2 things, right? I want to have, on my cat example, I want to have the get properties with 2 properties, cat list, which is an array of cats, and I want to have cat index, which is basically a number that defines the ID for a relevant cat. So cat number 0, number 1, number 2, number 3, right? So they have a unique ID. Unique ID are important for many reasons, especially if you want to delete something later. You need to know what are you deleting, which are the elements that are you deleting. So we define them in this very special way, a static get properties. And again, I don't expect you to know everything by heart, but we are doing a static, something that won't change, right? A getter, it's called properties, and it returns an object, a JavaScript object, with a series of elements, cat list and cat index, that have a specific type. One is of type array, and the other one is of type number. On the constructor, once more, the constructor of the class, of the Instacat class, needs to call to the constructor of LitElement, right? To the original constructor of the class that is our parent. So what we do is we say, hey, LitElement, do your stuff on the constructor, but also initiate, right? A start cat list as an empty array and cat index with a 0. Once more, I don't know this by heart, or I didn't know this by heart when I started. So this is the different ways that we have, right? Because if I'm sending you properties or attributes on an element, in HTML, everything that I put like, div ID equals a text, image source equals a URL, all of that is just a string of text. So we need to tell LitElement somehow that this property, right, this attribute, property type, and then again, there is subtle differences between attributes, properties, values. I don't want to go into a ton of detail onto that, but it's important that you are able to convert, right, from a string that is the default in HTML to whatever type you want to be using. This is why we declare it. And there is 5 types that you can use: string, number, Boolean, array, and then the kind of jack of all trades object. So we're going to go a little bit harder now. We had our instacat.html. Now I'm going to create another JavaScript file that is going to be called cat-card.js. This is the second element that I'm going to be creating. Very important. From this slide onwards, you are going to need a local server, local HTTP development server to keep going, because the moment that you are importing other files, right, and we were saying before, the reusability, the encapsulation, I don't want to create a second element inside my first website, because if not, I create this very messy couple of files. What I want to do is I want to have them separate. I want to be able to use CatCard inside Instacat when I want. And I want other applications that are not a list like Instacat to use CatCard separately. So I separate it on a second file. Let's take a look once more at how this JavaScript looks like. First line, right? I import LitElement and HTML, nothing surprising. I start my class. I call the constructor of the parent class. This, by the way, could be avoided if you wanted, but I want to be consistent for this example. I create some properties, cat ID of type number, name of type string, and an image of type string. I want you for now to kind of forget about the blue area, but look at what I'm doing on remove instacat. Remove instacat is an event. It's basically a custom event. You see, I'm doing dispatch event, which is basically the cat card yelling to the world, hey, someone click on my remove button, do something about it, right? And what I do is, with this dispatch set event, is a new custom event that it's called remove instacat. And on the details of that event, we have the cat ID of that cat. Do you remember when I was saying, why are we using the cat ID? It's because, right, I wanted to have a reference. So mostly I can refer to myself, right? My name is Victor Sanchez Belmar. I have a country card with a number, but that is unique. Being able to have a unique ID, it's really important in development. So what I have is this ability, right, of somehow I am launching an event. And we'll see how in a moment. In the HTML, look at how simple this is. A paragraph with my name, an image with my image. Of course, make it accessible on the alternative text in case that you're having a screen reader or something like that. We define that that's a cute cat image. And then you have a button. And remember when we were doing the bindings before on lit HTML, and I told you that we will be using those events? Look at that. On a button, when I click it, I want the function with the function array, with the arrow function, right? I want that when you click the X button, you call to this, my own class, dot remove instacat, which is the method that we just saw. And in that case, it doesn't do anything. It only creates an event, which is the equivalent of, hey, parent class, I'm going to be deleted. Do something about it, right? Delete me because someone clicked on that button. So it's really simple. I mean, this element has 27 lines. That's crazy. And look at, it's doing quite a bit, actually. It's defining the data structure, it's defining an event, it's defining a method that responds to that event, and it's launching a custom event up to that hierarchy. By the way, on the detail, if you are familiar with custom events, you will probably miss some things. For instance, the property bubbles. When an event, we call that an event bubbles, it means that it can go up on the structure of the DOM. So that event basically propagates to this whole DOM. In this case, because of how I'm using these components, I didn't need that, right? But probably in other examples, I would like my events to bubble up, bubble down. There is ways to do that, and they are in the documentation. So let's try to use that. How do we use our new cat card JS element? Basically, I create it in the way that I told you, and you see how I'm making ID equals 1, names equals Simba. I open my cat card tag. I call it ID equals 1, names equals Simba. Image is, of course, I'm using the magical website. If you don't know it, you have to. Called placekitten.com, and you pass the sizes, and it gives you the random cat image. That's super cool. And then the only thing that I had to do in order to use that tag was I imported it. I did import cat.car.js. This is why you need a web server, by the way, because for the import to work, you have to be serving it. You cannot serve it from your local file system. You have to, for security reasons, you have to do it from a web server. And that renders that beautiful cat with Simba, the name, sorry, the random cat, and the button to close it. In this case, when I close it, it won't do anything because no one is listening to that event, right? But I'll show you more on how to continue that. But again, super easy, right? I created a 27-line component. I used it in 3, right? Very, very easy. By the way, the import is because I'm using other things, but you could actually, the first import, right? The one that imports lit element and HTML, but in order to use it, you are fine with the other one. So let's post cat pictures now. I'm gonna be doing some additional things on the class element, right? One of those was, again, I created the static get properties with the array and the number, the constructor. Second, let's take a look at the post instacat. So what I'm gonna do is I'm gonna go to my input that I generated. I will show you then in the structure. And on line 35 of the second point, right, I have constant input is this dot shadow root dot get element by ID. So remember when I was telling you before, I don't want to look on the whole document. I want to be able to look only from where my element start and then inside. So this is the example, right? I don't want to look on the whole page. I don't want to do like document.getElementById and look in the whole thing. I don't need to, because I know that my @cat input, right, where I have the name, I know where that is. So it's inside me, right? It's inside my own element. So I start looking on shadow root, not on the origin of the document. That is going to make it way faster. I take the text and I put the input, the value of that input, or random cat if not, line 36. On line 37, I clean it, right, just to be ready for the next operation. And then I create, because I know how the API works, I create a random number with between 1 and 16, so I can create the new cat list. And by the way, look at this, what I'm doing here. I say this.catList is equals to the original cat list element plus the new element, which has a cat ID, this.catIndex plus, name and a text, image and a text, which is the place kitten API, and I generate that. The magic of this is that when I change the cat list element, the cat list property, sorry, and I go inside my render function, lit_element knows that I changed a property, and then lit_html is smart enough to re-render my template without me doing anything. I am not saying anywhere, oh no, someone added a new one, you have to repaint it somehow. I am not writing that anywhere. lit_element and lit_html know that already. That's awesome. It's because, again, doing this in other frameworks, it was messy as hell. That's really awesome. So line 52 on the third block, forget about the rest, right? It's just the H1 that we are familiar with, the input tag. Now, a button tag, once more, add, click, do, post, Instacat, right? So one more, we are using the bindings to call functions, in this case, to call for actions, right? Then we have the div_id cat container, but again, no one will see that div_id because they are using our wonderful tags. This is hidden from the developer that is using this element, right? We have an unordered list, and then look at that. I am using the array map function to basically do an HTML template for every cat in my array. So for every cat in my array, I will create a list, right? That list will have an element inside. Inside an unordered list, I have the element of the list, right? And I have that cat card inside, which, and look at that green line. I will go back to that one later, for now ignore it. But cat ID is equal to $cat ID, name is cat.name, image is cat.image, and I create my new card. What that gives me is this wonderful result. I have Instacat with my input and my button. I put a name and post on Instacat, and I create a cat card element that gives me exactly the content that I wanted. Very, very simple. And again, 117 lines probably, something like that. The deleting cat pictures, right? Once more, remember, right, catcard.js at the bottom right of the slide. Remember catcard.js when I was launching the remove Instacat event, I was yelling, hey, please delete me, I'm ready. And no one was making any sense of that, right? Now, our parent element has a listener, a remove Instacat listener. And when that remove Instacat listener is called, it's basically triggered, right? Because I had heard that event coming from the element, then I do something about it, which is this.remove Instacat. And that basically is a filter function, lines 42, 43, and 44 on the top of the list. So basically this slide is written from bottom to top. I'm sorry. I will change it for my next event. This.cat list is equal to this.cat list.filter. Once more, this is a standard JavaScript, right? I am using the filter function on top of the cat list array. And I tell them, look, for every cat, look if the cat ID is different to the one that I have, and then you keep it. If it's equals, then it won't keep it. Therefore, you have removed the cat. By the way, once more, I am anywhere telling go to the HTML and remove the element. No, I am not doing that. This is magic. I am removing an element from an array, and automatically lit element and lit HTML work together to go to the render template to find that specific cat that I have removed and re-render that piece, only removing that cat without touching anything else. This, again, it's really hard, was really hard a year back, right? Making, a year maybe not, 3 years back, this was horrible. So doing this in this way, it's really awesome. Believe me, this is a massive change. Okay, we need some styles. I am terrible at CSS, but I had to try. So I only changed one thing, which is I styled the title on that. Look at that very Instagram-like font. This is an open source font called Run Hotel. I'm using Google Fonts to import it. But I wanted to change, right, that Instacat. But wait, how do I do that? How do I style inside my element, right? Inside that shadow DOM. So CSS in web components, it's exactly as simple or as hard as real CSS3 would be anywhere else, with the difference that there is a couple of special selectors. I will teach you one today. The one that I want to be using today is the host tag. The host tag allows me to basically, it's a special selector that allows me to select inside the shadow root. So it was an H1, right, the Instacat one. So I do host, the space H1, and I select the font family, grand serif, and the font size, 48 pixels. And I really quickly am able to change the font, right, for that one. If you wanted to style this more, and I'm sure you want, because this application is very cute, but it looks horrible because I'm not a designer, I'm sorry. But you can actually real quickly, right, put some CSS on it and make it way more Instagram-like and way more likable, even though the cats already help. But you can definitely do that. So I hope that you learned a lot today, but the reality is that learning web components in 51 minutes is not a realistic goal, right? You're gonna need to do a little bit more if you want to. I recommend you to go to 3 places after this talk if you are interested. First one, to Open Web Components, open-wc.org. These guys have done, because web components are a part of much larger web applications, right? Nowadays, you have to develop with a development server. You have to lint to make sure that your code is pretty and respect the standards. You have to test, you have to build, you have to demo, you have to deploy. You want to automate those deployments. So there is a lot of more things, right, inside your PWA, that's a topic for another talk, progressive web applications, that you are going to need to do in order to do modern web, right? So web components is a small part of a very big puzzle. And open web components have guide, recommendations, generators, tutorials for this part that I did today and many others. So open-wc.org, amazing resource. Also, the Lit Element website, of course, and the Lit HTML website. And finally, you can always follow me on Twitter at Victor Sanchez and ask me any questions that you may have about this talk. I hope this was useful. It was a little bit longer than I anticipated because I wanted more time for questions, but we still have around 8 minutes for questions. So if there is any questions, I'm happy to answer now. If not, I will see you later in Twitter, and I'm happy to reply. So how did you like that?
Well, thank you very much. It was quite interesting. I also like the way you express, because you do look like a fan. I remember the days when we had to use jQuery just to, combine about 100 elements and make them interact, and that was painful. And I guess it's worth mentioning that the whole problem was all those stacks and libraries that we usually see building up in the web development area, is because web development is probably one of the most one of those who have to support previous generation of everything and stack it up and carry it with us. Which is why lit elements and web components in general, they are basically providing something that will give you some more comfort while developing, while still not breaking all the stuff that have been developed before you, because that's not going anywhere. I mean,
and that is really important, right? Because the cat car component that we created today, we could go to that 1991 website and will it still work inside that website? And that is the magic of the web, right? It's not only interoperable, but it's infinitely retrocompatible almost. And that's something that is really hard to do.
Well, yeah, that's what I was going to ask. Does it support Explorer 6? Because if it doesn't, why are we talking about it?
So it does support Explorer, not Explorer 6. I'm sorry to say, but there is something called polyfills, which basically will simulate the APIs on older browsers. But if you are still using Internet Explorer 6, I'm going to use this platform to please call whatever administrator you have on your network and ask for mercy. Stop. Okay, I mean, Explorer 6 broke the web. So if you are still using it, please don't. I mean, don't torture us any longer.
Yeah, well, anyway, currently Web Components are supporting all of the major front-end libraries that you might be using. So one of the things that you should consider while looking at it, it's not just yet another JavaScript library. It's a whole subset of techniques that can be combined with your current front-end stack, be that React, Angular, and so on.
Sorry to interrupt. There is this website. I use it all the time. It's called caniuse.com. And this caniuse.com will give you compatibility grids for anything. So if you look, for instance, for custom element, right, and you look on here, it will tell you exactly which browsers, you see, will support custom elements and from which version they do. So if you have a question of anything, right, basically any web technology, can I use it where? You can actually come here and come directly and see which browsers will allow it, which is really, really cool. So that is caniuse.com. It's super useful. Sorry.
Yeah, and also you can use that caniuse.com for that web developers game when you have to find out the word that doesn't have .js library named after it.
Yes, correct. Absolutely, absolutely.
Okay, thank you very much for your joining us, especially on Sunday. I mean,
our pleasure. This has been really, really great. Congratulations, guys, for the event, guys and girls, of course, for the event. It's been a pleasure to follow. If there is anything that I can do and help in further events, I'm super interested in continuing helping the community. So again, congratulations and keep enjoying the event. It was a pleasure. Goodbye.
Okay.
Thank you. Bye.
Bye-bye. Thank you. Cheers. Bye.
So that was it for using web components in modern web development. I really suggest everyone just to at least pick and try, give it a little try for at least like a week or so, to understand the concept. It might prove useful once you have a web development project with many elements that have to interact with each other and that are being developed in different teams. So there should be some inheritance and interoperability without actually like grabbing your teammates and colleagues to explain you what's it's all about and how do you use it. Our next speaker is going to talk about Flutter. Mr. Gazihan Alankush, right?
Yes.
Yes, that's right. Thank you.
Hi.
How are you?
Hi, I'm good. Thank you. How are you?
Fine.
Well, it's Sunday, so we are experiencing Sunday as well, you know.
Laziness.
Yeah, sure. But we hope that most of our viewers will see us after the after the actual stream. And right now, I'm giving you this stream to talk about using async and await in Flutter.
Yes, thank you. Thank you for inviting me. It's an honor to be here. I hope everything was fine before me. I tried to watch a little bit, and you cannot top that last talk, of course, but I'll try my best. Yeah, so today I'll talk to you about practical async await in Flutter, and I'll talk about myself very briefly, and then I'll go into it. So I'm from Turkey, by the way, not very far from you. I wish there wasn't COVID so we could meet in person. I would be interested in coming over. But yes, so let's start. So I'm from Turkey. I studied here and then went to United States for my PhD, and I got to be an intern at Google for 3 months, where I met Dart before it was released. So, and I got to play with it for a long time. I really liked it, especially I liked the async await things in it. JavaScript didn't have, promises weren't very popular back then. Async await wasn't heard of. So I really liked it in Dart before that. And after I graduated, I came back to Turkey, to Izmir. I'm teaching at a university here as a faculty member, Izmir University of Economics, in the engineering school. I'm teaching mobile application development and game development in my courses. I teach Flutter and React Native in my mobile app course. And last year I founded a company where we are developing some Flutter projects also. So that's my background. But yeah, if you're ever in Turkey, in Izmir, feel free to ping me. I'd love to show you around. Okay, so because of my profession, right, since I'm teaching at a university, I see a lot of people who are trying to learn Flutter. I'm teaching them. And also I try to be active in Stack Overflow. Something that I see often is people say, oh, I want to learn Flutter. It's nice, it looks good. And then they skip on learning async await properly. So they glance on it, they see, oh, futures, async await. They just save the day, and then they don't know it very well. And then they say Flutter is hard. They get all kinds of weird bugs because you get to use it early on, and you have to use it, async await futures. And if you don't learn it properly, then you'll have a lot of bad time. So you see code like this all the time: await, async, future, whatever. We don't teach JavaScript, by the way, in my course, but there are other courses. I'm sorry, I'm distracted by it. Maybe I should answer later. Yeah. So what's all this future async await stuff, and how should we use them in practice is the question that I'll try to answer today. But yeah, in my React Native course, I teach some JavaScript. In my React Native part of the course, I teach some JavaScript. In the Flutter part of the course, I teach some Dart. But I leave it to the students to figure most of it out. I just give the basics. Yeah, feel free to ask questions whenever. And so I said that you early on meet async await and futures. So I personally, found it through the file class. I was trying to open some files, write some things in files, but I was opening the file, and then when I tried to read, I was getting an error because the file wasn't open yet, actually. It was returning me a future. I wasn't dealing with it properly. I wasn't awaiting on it. So the file reading stuff should come after the file was properly opened. But I wasn't waiting for it to be opened. It was giving me a future not to make the main thread wait. It took some time for me to realize what's going on there, but with some Stack Overflow answers, Günther especially, you can see him on Stack Overflow, he was very helpful with that. So I figured it out. But whenever you're trying to do something in Dart and Flutter that takes some time, you have to deal with these futures and async await, and you have to understand it to write, bug-free code, basically. And when you're, of course, doing HTTP, there's some delay, right? You request, the response comes later. There has to be some asynchrony there. And even when you're showing a dialog, right? You say, okay, let me show a dialog in my app, and the dialog asks something. It takes some time for the user to answer. When the user hits yes or no, the future completes, and my code can go to the next line, knowing that it was yes or it was no in the same function. So this is very powerful, and a lot of people don't think it this way. But when you use show dialog like this, or even navigate to push like this, it's very powerful. Your code makes much more sense rather than let's go to that screen, let's come back to this screen, etc. So if you know these things well, you'll have a lot of good patterns you'll be catching. So And early on, you also realize that you can use futures with async await, right? You can use futures. So I talked about futures in the previous slides, and you can use async await with them. Somebody shows you, hey, you could use it like this instead, and then you say, okay, and then you don't properly learn it, and then you get all kinds of weird situations with them. So today I'll try to, motivate some questions and try to answer them as much as possible. So theoretical first. So what are these futures? What are async await? Why do we have them? How do they work? Should I really understand them, or just save the day with Stack Overflow, which I try to answer? You should really understand them. So that's the first part I'll talk about, a little bit theoretical, but then we'll switch to practical. How should I use them? How do I do X? And if you have other questions also, we can add to this practical list. So let's talk about the theoretical part. So these features are there to help make the most of a single thread. So Flutter is single-threaded. Some people see this as a downside. It's actually a very good thing to have, because multi-threaded code is very error-prone, and people aren't, a lot of people aren't good multi-threaded programmers. So we have a single thread that keeps things much simpler than it could be. But we also have an app that responds very smoothly. So we never block this single thread. We have things that take time, like going to the cloud, getting things, and even going to the file system takes some time. The reason for having these features is to keep the main thread unblocked, so things that take time come back as events to us in the future when they are completed. So let's motivate it with a real-world example. I developed this example over a bunch of talks, but I kind of like it. So it's like not to spoil a date, somebody told in one talk. So let's say you went to the mall with your friends are sitting, and you want to go pick a hamburger, right? And nobody likes to wait is the title. So you're going to go and ask, hey, give me a hamburger, please. Here's the money. And they say, wait 10 minutes, please. So what do you do at that point when they tell you to wait 10 minutes? You probably, of course, bring up your cell phone, play with it. But what about your friends? They will be sad when they are sitting there and you're chained to this place, waiting for 10 minutes for your hamburger, right? Your date is probably spoiled. So this is like in code, this is like you have an event handler, and hamburger is equal to wait for hamburger. So this is a synchronous line-by-line execution. Execution goes into this wait for hamburger, and there's maybe a for loop or something that's not releasing the execution back here. This function is not returning. So as a result, you cannot go to this, eat hamburger, or you cannot go to, talk to your friend. Those kinds of lines of code you cannot go to, right? This is the example, and this is when your UI is frozen and you're moving the window around, painting the screen. Sometimes I'm sure everybody had that. So we don't want this. We don't want to make the UI thread wait. Instead, what I could do is some restaurants give you this pager, this little thing that buzzes when your hamburger is ready. Normally, it's not lit up. And then they give it to you. You go back to your desk. And then when it's ready, it lights up. And then you go pick your hamburger. This is the perfect analogy to a future object. So they give you a future instead of the actual hamburger. And then you go back to your table. And then everybody is happy. You eat your food. And then when your hamburger is ready, they press a button. Your pager buzzes, lights up, you go pick the hamburger really quickly, you eat it with your friends, everybody is happy. So we want to have this kind of a thing going on in our code. And if we think of it like code, so earlier in our event handler, as you remember, it was a synchronous wait for hamburger function that wasn't releasing the execution back. Here we have an ask for hamburger that gives us a future object, this pager. And then with that pager, we can do things like when that pager lights up, execute this function. Not right now, but when the pager lights up, execute the function. And exactly the same thing is over here. So this is the syntactic sugar async await version of it. Ask for hamburger still returns as a future, but this await keyword magically gets the hamburger out of it. And then we eat it. So how does this happen? It actually, this above code is executed, but your code looks like this. Under the hood, the above code is executing. But this, to the user, to the programmer, it lets you write code like a synchronous version of it. This is very powerful. So actually over here, the execution is released. It can go do other things like refresh the screen. And then when the hamburger comes in, then this line continues to give you the hamburger. So I'll be talking about that a little more. But basically, this is what's going on. You're getting the pager, and then when the pager buzzes, you're doing something else in the future. Right, yeah. So we get the future. To the future object, we attach a function with then. And in here, everything is happening in this one line. And then this code is not executing, right? Eat hamburger part is not executing. And your function actually returns. And similarly here, this code is not executing. It remembers that we were here. This white arrow is that. So it remembers that we had a future. When the future completes, we'll continue here. It remembers that we have an await. When this future completes, the await will let the execution move here, the function to progress. But the execution itself, the thread itself, actually went outside of this function, which is really powerful. We didn't hold the thread hostage, right? And when the hamburger comes in, your pager buzzes, your future completes. Then your future remembered that there was a white arrow earlier here. It remembered that we had this thing function next to it, and when it's complete, it actually executes the function. You eat the hamburger, okay? So top and bottom are equivalent code, and that's how it executes. Part of it executes in the future, in the above one, in the below one. The rest executes in the future. But your function actually was able to return immediately because this returns a future. This just returns a void. Nobody uses them. Okay, so that was a real life analogy that I tried to give, but when you're explaining it like this, it's always hand wavy. Oh, imagine that this is happening later, etc. So now I want to give a very concrete representation of what's going on in the computer. Okay, so no hand waving here. If anything is left out, feel free to ask. I want to make sure that everything is covered as much as possible. So you have a processor, right? This is how we learned how to code. There's some code. And line by line, that code is executed. That's how they taught us how to write code, right? How code executes. This is synchronous execution. This is your thread. There's one thread in Flutter, like I said, one processor, one thread. And this thread moves on line by line, executes. The thing to notice here is that before this line is executed, completed, I cannot go to the next line, right? So if one of these lines holds the thread hostage, the rest cannot continue, like the earlier hamburger example. Okay, so let's, we have it in our head. This is how it is in Flutter. We have an event loop, also in JavaScript. You can think of it like that. We have in our main thread, we have an event loop that keeps, it's like while true, keeps turning, okay? And our event loop, for a bunch of reasons, calls sometimes our functions. For example, a button is pressed, our function is called in the event loop. Event loop keeps turning. When I press the button, event loop calls that function, right? And then there are other functions that the event loop calls also, right? Blocking one will prevent others, as you can imagine. So event loop is executing. I press the button, let's say, my function got executed. So as you can see, my thread is here. It cannot go over here without me letting it go. Okay, and it returns. And then there is another function that refreshes the screen that comes from the framework. It goes to that function, refreshes the screen. So what does this mean? So for example, I pressed it and I moved my finger below. The contents should scroll down, right? This is the function that redraws the screen. So the contents move down and I feel like, oh, it's responding to my finger. So it has to go into this function like 60 times per second. Okay. So this is the regular execution. But then sometimes in my function, I start like a large download or something that takes time, keep the thread hostage here if I can do that. Then the thread cannot go to the function that refreshes the screen. It's not responding. My finger touches it, it's not moving. And then, Android says, this is not responding. Should I kill it? Even though it's actually doing something. So actually, we cannot have this in Flutter. If you do like a while true, perhaps you could. But with regular usage, like downloads and things like that, you cannot have this. They did it so that they created the standard library so that everything returns you a future if it takes time. But in some other frameworks, you can do that. So you don't want to do that. Instead, you don't want to be chained here. You want to get a future. You want to get a pager that will be buzzed sometime in the future, and you can continue your work here, right? This pager, as you can see, this line 5 that I have here, after the download finishes, we give that as a separate function to this pager. When things are done, when download is completed, execute that function with that line that uses that download result, okay? So it's a separate function. And then line 4 executed, and we let the thread go. Everything is fine. And we have a now separate function that did not execute yet. It will be executed when download is complete. And the pager, the future object, knows about that. And then we continue our event loop. We are happy that we can refresh the page, right? Everything is scrolling smoothly, even though the download is happening in the background. The framework is taking care of that for us. We don't care about it. When it's complete, it's going to let us know. And we move on. And then there's actually another function that continues unfinished tasks that I wasn't showing you earlier. So whenever this buzzes, that function will get, call this function that to execute when download is complete. So let's see that. So let's say as the event loop is progressing, download is complete, the future says I'm complete. The buzzer buzzes. And then the thread is moving on. It doesn't immediately go there. It just continues. It goes to the function that continues unfinished tasks. And then it looks at the completed futures. It says, oh, this future is complete. The download is there. Hey, dear future, where is your function to execute when you're complete? It says, yeah, here it is. They gave me when they were creating it. And then we say, okay, let's go handle that. Use the download properly. And then let's go back here. This was quick. So that we can, again, go to the function that refreshes the screen, right? So my screen is still scrolling. Okay, so this is how it happens. We are given a future. That future is attached to a function. And our event loop, when that future is done, in this special function that continues unfinished tasks, it goes to the handler of that future, that function that we attached to that future. So this way, asynchronously, we were able to do other things. And when that was complete, when we were ready, we were able to go back to it and continue what we were doing there. Okay. So here's our function. Remember, in some frameworks, like I said, you can keep the thread hostage, and the main, the app seems unresponsive. This happens with downloads, but this can also happen with things like reading a file. Reading a file also takes time, even though it doesn't take as much time as doing a large download. It does take some time to read a file. And especially, I believe, when our Android phones got older and they got slower, Google Maps especially gets jumpy, I believe it's doing some file things or something that takes time that's not asynchronous. So the thing is, this event loop, if it takes t time, I'm just making numbers up, but this is close to correct. Let's say 60 frames per second, t amount of time it should take the event loop. Reading a file can sometimes take 10t amount of time. So that means that 10 frames being dropped, your app appearing jumpy when you're scrolling, your app stuttering. So this doesn't happen in Flutter, like I said, because everything is returning a future. Everything that takes a time, like reading a file, returns you a future that you can await on. Okay, so these futures or promises in JavaScript, if you're not going to wait for something, you need something like that, or an I owe you money, or I will give you this kind of a token you need, which is these futures and promises. Let's say the burger shop gives you a piece of paper. They give you a pager, or somebody gives you a box. They give you the box right now, but they say that this box will contain your answer. It will open by itself when it's time. Do not try to open it yourself at the moment. Okay. So it's like that. A future object is like that. They give you a box, but you're not allowed to open it yet. We see questions on Stack Overflow all the time. Hey, gave me a future. How do I get it out of the future? You cannot. It will happen in the future, sometime later. Sometime later, you are able to get it, so you'll know how to work with the future object. You need to learn. Okay. So this future object is like a middleman for callback functions, right? There is a producer, there's a consumer. Producer is the HTTP library. It downloads something, gives it to you. Consumer is your code. And when you say, okay, download this file, it says, here is the future. I'll give you the result through it once I'm done. So immediately it gives you something. And then you say, okay, I'll know what to do when you're done. It works on downloading the file, creating the result. And in the meantime, you can do other things like scrolling the screen. And then when the download finishes, it says, I'm done. Here's the result. You say, okay, great. I had attached a code to it. It will be executed. I'll use the result there. So this is kind of a broker between callback, between two entities. Rather than passing around functions, we pass around these futures, which is a standard thing. Functions wouldn't be standard. You would have to know too much about the two sides. This like decoupling the two sides, consumer and producer. So here on the left is regular synchronous code, right? Int get val returns 1, void main calls it, gets that result, prints it. Very simple as simple as I could, piece of code. On the right is the asynchronous version of it, right? So getVal returns me a future, and then I need something that gives me a future. Future.value gives me a future. It could be an HTTP request, something like that. As you can see, I am returning the future object. I'm creating the future object myself. I'm returning it. And then in here, I'm calling that getVal. It gives me the future object. What do I do with the future object? It is a then method. I say that then, and I attach a function to it, which will be executed in the future. So this is the bare minimum usage of futures without any async await, without anything like that. Similarly, we have a stream class. This is very often used in the block pattern, which you had a talk today earlier. Similarly, you have a producer and a consumer, but the producer creates multiple results. Here's a result, here's another result, and your attached function keep executing. Okay. For example, you can get the stream of the keyboard. Every time the user presses a button, your stream gives you one more entity. So similarly, the sync and async versions of things. So stream is a feature for multiple objects. So what's a multiple object thing? We have an iterable. We have a list, which is a iterable. And if I have an iterable, I can do a for loop on it, right? If I have a list like this, I can do a for loop, for in loop, to print every element. If I have a stream, what do I need to do? Similar to the future. Now, it doesn't have a then method. It has a listen method. I attach a listen method to it, listen object function to it, and that function is executed every time an entity comes. So these are very bare usages of them, as I said. I'll show you better ones coming up. So, okay, so this is the future object, stream object, and they have so many methods, so many usages, etc. But I want to get to async await, the better way of using, easy way of using them. Async await makes things easier. So future is great, but writing sync code is easier. So if you look here, the code on the left, the synchronous code, looks much cleaner than the code on the right, much more, much less error prone, and much easier to understand. So it's hard to write async code if you don't have something like async await. But Dart language and standard library have async support, which makes writing async code very pleasant, which I'll cover here. But there is other things, sync star, async star, yield, etc. if you want to create streams with functions, generators. But let's just cover async await here. Okay, so remember the earlier future example with the sync and the async. The red stuff is the new stuff. So remember, we were returning a future, and they were using with that then. So in the center code, as you can see, this code on the center looks very much like the code on the left, and not complicated like the code on the right. But the only additions are this future return, asyncs, and the await keyword. But as you can see, it's line by line. We're not introducing a new function, new inner function. This is very powerful. You can have for loops, try catches. You can have different branches. One of them has an await, one of them doesn't, which you couldn't do with this. So let's look closely here. As you can see, the first one looks similar. My getVal returns a future. It has an async keyword here. This async keyword lets me return the value that the future will send over. Instead of creating a future myself, instead of returning a future myself, I am able to return the value of that future. Okay. So let's say before this line, I did some things that took time, and then I can say, okay, I'm done, return 1. And the future that we returned over there, this 1 would be sent over to the then method. Okay. So this async keyword lets you return the value that and wraps it into a future for you. And if you have an async keyword, you can also use await keyword in your function. You can change your main to async like that. And this await similarly lets you use this future like synchronous code. It actually waits here. It lets the execution continue otherwise. And when this future completes, it completes this line and then gives the 1 that you gave in the future to this val and then prints that. Okay, so this looks very much like synchronous code, sequential code, but it's actually this one on the right. Okay, so this is the best of both worlds, and you should use that rather than dealing with futures bare directly. Okay, so the whole point is, how do we continue after a time-consuming task, right? In the synchronous code, you go to the next line to continue. You know, wait for your hamburger. You got your hamburger. You continue in the next line, which is easier to program, very bad for the interactivity because you are actually pausing the UI thread. In the async version, we are creating a separate function. These lines at the end become a separate function, and you're giving that function to the system. Hey, please call this function when that time-consuming task is done. So this blue task starts, and then I attach this as a separate function, and other things go on. And when that is complete, I continue with that separate function. So I'm not in the same function anymore. I cannot do a for loop, if around it. I cannot have local variables, for example, since this is a separate function. You can have closure, of course, but not, you cannot have blocks like if, etc. that are shared. Okay. Async await is the best of the both worlds. So you go to the next line to continue with async await. You put an await here, you go to the next line to continue, but it actually works async like the below, right? That's actually behind the scenes made a separate function for you. And then you can do other things. And when things are done, then you can, that part completes. So this is the best of both worlds. You can code it like sequential synchronous code, but it actually executes like asynchronous code with the future. Right, so next line, async, best of both worlds is the using async await. So never use futures or streams directly unless you have a very good reason. Always strive to use async await. Okay, we talked about futures and single values, and we also talked about multiple values with stream, like the one on the left and the one on the right. We had a stream, and we were saying .listen. And these codes are just one way to create the stream. Of course, you would be given a stream by someone else, like the HTTP library or something like that. So you were able to write a for loop around the list, around the iterable. You are able to write an await for loop around the stream. So this can be a little hard to understand the first time you see it. So somebody gives you a stream of the keyboard. Every time I press a button, stream sends over one value. I can put a for loop around that. So every time I press a button, the for loop, await for loop turns one more time, and it waits for me to press a button. So this is very powerful like that. Every time a byte comes through the network, my for loop continues one more time. The good thing about it is you're still in the same function. You can have local variables. Your state can be in your local variable. Your state can be in your, which line you're at is a part of your state, for example. Otherwise, you would have to store things in fields, etc. Callback function is executed. Let me update my fields. Writing socket programming is very easy like this. Okay. So far I talked about async in Dart, right? How it works, how it is behind the scenes. So what about Flutter, you may want to ask. Of course, if there are any questions, I'm happy to answer, but maybe one more time I'll go over. So this future is, you have one value, regular synchronous value. The asynchronous version of it is a future. This is a future that gives me an int, okay? And the asynchronous version is, you have the future, you say .then, and then you give a function that will execute sometime later, right? And then you have a stream. Like I said, the above code, don't worry about it. This is just one way to create a stream, but you would get that stream through a call to some library usually. And in synchronous code, you can do a for loop around an iterable, print all the items one by one. In the asynchronous world, you can do .listen to a stream, or you can use the await for, like I said. So when we're talking about the future, rather than saying .then to a future and attaching a function to it, instead you can say await before a future. So this getVal returns me a future. I can say await, and the execution will actually return from here, like the example that I showed in the beginning, the hamburger example. And then when this future is complete, when this one is given, then I come back to this line and then continue the rest of this main function. So it actually executes like two separate functions, but I write it as one single function. And for the programmer's purposes, it's like a one single function. You keep all the local variables, the state, try catch, everything you can keep. And having the async keyword forces you to return a future. And I can actually show it very quickly. For example, let's create a int getVal return 1, right? So I can have a function like this. I can say convert to async function body. As you can see, when it added async, it also made it return a future. It's wrapping this one around with a future. This is very powerful. Also, the IDE features I will talk about a little bit later. Okay. Similarly with the async, when you have a similar with the stream, when you have a stream, you can do an await for around that stream. Every time a value comes over, you print that, and you wait. Your for loop waits for a new value to arrive. Okay. So this is also very powerful. Okay. So let's try to dive to the practical side of things. This was all theoretical, almost half of the talk. Let's talk about the practice. How should I use them? How do I do X, right? And I'll try to give you some examples. First, again, motivated. But Flutter has async support also. So far what we talked about was Dart, the language Dart. But Flutter also is aware of these async await features. Flutter is all about widgets, right? User interface elements. There are two widgets, Future Builder and Stream Builder, that Flutter provides for us. These directly support asynchronous. You give a future to a future builder, it works with it. Similarly with Stream Builder. You can use that, but if you find it too boilerplatey, too much code, it looks like, you can also handle your own futures and streams. You can use async await yourself, but sometimes there are things to be careful about because of, one is Dart, one is Flutter. Dart doesn't know about Flutter, and Dart functions continue executing even though you went to some other screen. I'll talk about that bug that you can have. And the block pattern that you saw earlier today heavily uses streams. So before using block, make sure you understand streams really well. Practically, you can use them, etc. Because I see a lot of people, they start Flutter, they immediately jump into block because somebody tells them it's the good thing to go with. But they don't know about async await as well as they should, and then they run into all kinds of issues. Okay, so Flutter's UI architecture, you may have heard, it's all widgets, right? We have these user interface elements that's like a tree of elements that's getting smaller and smaller on the screen. If you have the data, then you can create this. But if you don't have the data will arrive in the future. What are you going to show to the user, right? You have to show something immediately. You have to it should be responsive, right? The user shouldn't see a frozen screen, white screen, or something like that. So what do you do in the meantime is the question, right? If you don't have the data, then you can use the Future Builder widget, just like adding a text on the screen. You can add a Future Builder on the screen and give it a future. You're saying that, okay, I don't have the data yet, I have a future for it. And with that, I will create this future builder that will take care of things for me until the data arrives. When the data arrives, that will use it. So initially, what future builder does is calls the build method that you provide to it, build function that you provide to it. It tells that function, hey, data is not there yet. What should I show? And there you show like a circular progress indicator or whatever you want to show, basically loading. Excuse me. And when the data arrives, when the future completes, then it calls your build method again. So you are able to actually build your UI with the data that is here now, that wasn't there before. Okay, so future builder makes Dart work with async. Stream builder is the same way, but multiple times data arrives. So for example, like on the corner, you can have like a Forex dollar versus euro, something like that. As it changes, let's say you have a stream from the server, as it changes, you see a new thing appear every time another value arrives through the stream. We use this heavily in Firebase. Flutter and Firebase work really well. So you can listen to a Firebase Firestore path, and then every time somebody writes something there, you see it immediately over here if you use the stream. And here is the code. On the left is the future builder, on the right is the stream builder. So as you can see, this is the build function. This is where we create our user interface. We are creating a column. This is the regular kind of user interface. I could, there's the children. I could put a text here. I can put a container here, etc. These are the regular user interface elements. Similarly, I can put a future builder if I don't have my future, if I don't have my data yet. if I have my future for it. So I need to put that future into a variable in my class, into a field, which I'll talk about later. So don't have a function call here that creates the future over here, and which I'll talk about soon. But we have the future. We are giving the future to the future builder with the future parameter. And we're giving a builder function to the future builder. So this builder function is executed by the future builder a bunch of times. Initially, it executes if there is no error initially, but snapshot has data is false initially. So it executes that with this, and you get to show a circular progress indicator initially. So when this is first created, this part of the code executes, so you show a progress indicator. And sometime later, when the future, if there is an error, it again calls this, and then it says snapshot has error, snapshot.error has the error, so like the try catch. But if actual data arrives, then it calls this your function one more time, this inner function, and no error, there is data, so you get to return the actual row with the icon, text, whatever that comes from the snapshot from the future. Okay, so this is how future builder works. Exactly the same thing with stream builder, but the stream gives you multiple data, so this is called multiple times, so you get to create the row multiple times. Only once you show the circle progress indicator. Once you have one data, then new data arrives bit by bit. So the alternative, if you don't want to use this, so yes, this is good, but this can feel a little boilerplatey, right? It's too much code. Where is my code? All these ifs, etc. You may want to handle it yourself. How do you do that? In your init state, this is a pseudocode. In your init state, you can start an asynchronous job, which I'll talk about later. You can do this. You don't have to await on everything. And this is like starting a thread. And your init state has to return immediately. And then it starts this. And this one, and in your build function, since your state variable is null, this didn't execute fully yet. If state is null, you return loading. Okay. And since we started this is waiting on this obtain, let's say HTTP request, something like that. It was awaiting on it, build function executed. When this completes, then you can have your variable R contain the result, and in your set state, you can give it to the state variable, and then your build function can execute one more time, showing the actual data. So this is more or less like future builder. Okay, you can handle your async yourself, awaits and set states following those awaits. Okay, so this can feel a little more cleaner. And if you have multiple things, multiple futures that will be coming up, then this may be cleaner to use rather than a bunch of future builders nested. But there's people all the time run into this issue when they try to do this. You see the set state called after dispose bug, dispose exception. This is happening because your user info widget, this widget, actually moved out of the screen. So it's not there anymore. It's not in the widget tree anymore. But Dart doesn't care. You started this async function, it's going to complete. So when it obtained, it calls set state, but it's not there anymore, so you get this exception. Okay, this is why you get this exception. This can be okay actually, but there are ways to avoid that. But if you don't want to avoid that, sometimes it's also fine. What do I mean by that? So if you want to avoid this exception, you can replace your set state with something like set state if mounted. You can do find replace. And your set state if mounted can be checking the mounted Boolean, which means that am I in the tree or not? And if it's mounted, then call set state for you. So you don't have to do if mounted everywhere. This is easy to do. Or you can have if not mounted return right before your set state after each await. Or you can just ignore this exception because this exception is saying, okay, you want to put something on the screen. You're not on the screen. You cannot do that. It's an exception, but the nice thing is, the function cannot continue. If there were other set states, it cannot continue. It just gets out of here. This is a good thing, actually. This is an exception that function should not continue. This is just like if not mounted return. You just see something in your logs. I think you can sometimes just leave it alone. It's actually helping you not continue by raising this exception. So you have 3 options here. And in some of our apps, we are actually taking this approach sometimes now. And this is the code with the set state if mounted I told to you about earlier. So you just write this function and you replace all your set states with set state if mounted, and you don't get that exception anymore. but your functions will continue if there are other stuff after that that will continue. But you avoid that exception easily. Like this is the easiest version of avoiding that because find replace is very easy. Okay, like I said, you can start an async function like a thread. So what do I mean by that? So your init state function, you cannot have it be async. It has to be normal function, sync function, because you're overriding it from the parent class, and Flutter expects it to be a sync function. And you can here call an async init function that you created, which returns a future which takes some time. But as you can see, we're not doing anything with that future. We're just throwing it away, which is fine. You just get into the event loop like this. It will continue executing, but you don't wait for it, which is fine. This is like spawning a new thread. It works like that, which was the case in our example that I showed earlier. But if you're doing this in an async function, this is likely a bug because you maybe forgot to await on it. Maybe you meant to await on it. For example, when you open a file, you get a future. You assume that file is open. It's very easy, right, to open a file. But no, it takes some time, so it gives you a future. If you don't await on it, you run into issues. So you can, if you want to use the this analysis options file, if you put unawaited futures here, then if you did not await on a future, it will warn you, hey, there is a future here that you didn't wait on, which is very nice because you actually do sometimes forget to wait on futures, creating bugs. Okay, so that unawaited that comes from package pedantic helps you avoid those bugs. There is IDE support. So for example, you created a function start counter. I hope you can see this, and you hit Alt Enter. It says convert to async function body and then converts. I showed this to you earlier, actually. It puts the async, makes the return value future. Always it has to be future, even if it doesn't return anything, because the person who uses it needs to see that. Otherwise, you have no idea if it's an async function. For example, you have a sync function and you want to await something. It says, oh, you cannot do this. Well, you go there, hit Alt Enter. It says add async modifier, because of this, and then it does it, and then everything is happy. Similarly, let's say you use the function that gives you a future, some HTTP request or something. You hit Alt Enter, got this var future. You can add type annotation. It says, okay, this is a future, so you deal with it. You say, oh, I should have awaited it. I didn't want the future. I wanted the actual result. You hit Alt Enter again, you get the int. So I play like this. I code like this a lot to figure out what I'm going to be doing. I think this is what I show in this screen. The bottom part is an easy way to deal with functions that return futures. Okay, and earlier, as you remember, the init state, we were saying it has to be sync. It cannot be async. It actually lets you write the newer Dart versions. It wasn't possible earlier, but the newer Dart versions let you change the return value of the function that you're overriding. So this code, when you write it, it doesn't complain in the IDE. But when you run it, it says init state return the future. It shouldn't be an async function, etc., etc. Okay. So your init state, whatever function you're overriding, you shouldn't change it to async. Okay. You should keep the way it is. You should keep it sync if it's sync. But similarly, on the other flip side of the coin, you can make event handlers and such functions async if its return value is void. So for example, this onPressed function, there's a function here which returns a void, which doesn't return anything. It's a void function. You can make it async because the return value became a future. Who cares, right? And you can make it async. You can start up something here. You press the button. After 1 second, it will do something. It's fine. It just works. Okay. So event handlers, these inline functions, you can make them async. You can use await in them. But these overridden functions, init state, etc., did update widget, things like that, you cannot make them async. Your constructors, your build function, you cannot make them async. Also, your validators in forms, you cannot make them async. But there's a way to, there's a little trick that you can do to make it happen. And another suggestion is if you're using Stream Builder, separate UI code and async code for clarity. That's what I do sometimes. Stream Builder, async builder, like I showed you earlier, there's a lot of ifs in it, and you have to look around, oh, where is my actual UI elements, right? So this is what I do, actually. In my build function, I have an inner function, okay? really build inner function. Dart allows you that. It doesn't get called immediately, so it gets to here. There's a stream builder here. This is all boilerplate as far as I'm concerned. So standard code, boilerplate, it means that it's just standard code, that's filler code. It's not very interesting. So I have the stream, I have the builder, has error, shows you the error text, has data, calls the really build, otherwise calls circles progress indicator. These were switched in the earlier example that I showed you. But nice thing about this is all error checking, boilerplate, dealing with the stream code. This is my actual UI code. So I put it into a really build function. And when I look at this function, where is my UI code? Oh, it's in the really build function. I don't have to look down here. So this is one way to make stream builders, future builders less boilerplatey, clearer. Okay, so this is one thing that I talked about earlier, no side effects in the build function. What do I mean? So if you have a future builder or a stream builder or anything else in the build function, don't have a function that creates a future here, okay? So what is this code doing? This is a UI build, right? It's trying to create a user interface element, and there's a future builder here. And to it, I'm giving the HTTP call function called result as the future. So these build functions can execute multiple times for a bunch of different reasons. You have an animation in this widget, build function will execute again and again. Something changes on the screen, you press a button, now it's 5, counter is 5, this build function executes again. And every time this build function executes, this HTTP call function executes again, okay? So when the HTTP call function executes, it makes a request to the server. So imagine that in the worst case scenario, if I have an animation here that does 60 times per second builds, right, 60 frames per second, I'm making HTTP calls 60 times a second. I'm trying to do that at least, right? I'm starting these HTTP calls, bombarding my cloud, whatever endpoint I have. My bills will stack up and people say, oh, Firebase is too expensive. So that happens. I see it all the time. Actually, this code on the left is from Flutter's official videos where Andrew Brogdon teaches async await, because of course this is easier to show in a small video. But no, you shouldn't do this. If you look at this Stack Overflow question, Remy Rezulé explains it nicely. Maybe we can actually click it. Okay, trying. Oh, okay, I cannot bring it here. So if I did like this, yeah, in the Stack Overflow question, he explains it. He actually asks it himself and explains it nicely. This is the author of provider. So he explains very nicely why you shouldn't do that, why you should have the stream in a variable and create it in the init state if you can. Okay. So let's go back. Yes. So you shouldn't do this. Instead, what you do is init state is called only once when this UI element appears. It's called only once, and there you do your HTTP call. You remember its future that it returns, and then you give that to here. So what happens every time this is built one more time? Every time it's built again, it's using the same future instance. If we have already received the result, when you build it again with the future instance, your builder function is called with the data. Okay, it doesn't wait for anything anymore. Okay, so this is the way to go. If you're doing anything else in the build function rather than, hey, I have data, let's create the text for it, whatever is for it. Okay, but if you're in your build function, if you see function calls, be very suspicious. They can be doing side effects, and that's something that you don't want. Okay, so since we have a little bit of time, I want to show at least this part. Yes, so let's. Okay. So let me go here. So let's say we have a function that returns a future, for example, another async function. I want to use it in this async function, right? When I call it, I don't see its code. I just say another async func, right? I called it, great. And since I have the analysis options, it underlined it. There's a future here, it said. But if you don't have the analysis options, let's see, delete this because this is how it comes by default. As you can see, it went away. So you're not going to see that, but it's a good idea to add that analysis options function. Okay, so I come here. This is my practical usage of Flutter. I call the function, hey, let's put it to a variable, right? I assume that it's a value, right? I would be wrong if I continue. What I should do is I should also say add type annotation. Oh, it turns me a future, not a value. So then I should await it, undo. Well, maybe val, and then I can do an await here. Then I can say, well, okay, this doesn't return anything apparently. This is a void, so this is good. But let's find another. Let's write another function, maybe. Yes. Yet another. I could have used. Okay. So when I'm calling this yet another async func, I hit alt enter and then says, oops. What's the issue here? Forest close. Oh yeah, so the same name, that was the issue, sorry. and I can say add type, oh, this is a future, right? Undo, put an await here. Yes, I have my int now, so I can continue, okay? So this is how I work. Whenever I meet a function that I'm calling, I can show dialog. Like show dialog returns me what? It doesn't return anything, but if I do like bool, let's say he pressed yes or no. Why is this complaining? Yeah, the same name again, sorry. Add type annotation. Oh, this is returning a future, so I can await on this show dialog, right? And oh, this is returning a boolean, so I can put it inside an if. Something like this. Okay, so you can play with this, and the IDE helps you a lot in understanding what it is returning, what I can do with it, and if you always do the should add type annotation thing, you're not going to run into any bugs, and it will also help you. What can I do with this? What can I do with this? You can do a lot of thinking inside the IDE without actually looking at the documentation. Okay, so that's my talk, and there are some references, some of my talks, and Andrew Brogdon's great videos about async await, which I also mentioned earlier. Florian Loisch's talk was the one that made everything work in my head. I really appreciated that talk back in 2015. And happy async programming. I hope you like it. I hope you enjoy it as much as we do. And I have a company that we're developing Flutter applications in, and you can reach me with gazialankus@gmail.com or with the Twitter handle that I have, gazialankus. Yeah, feel free to reach me about anything. Some advice for beginners: touch typing. I always talk about this because I think it's important. If you print out something like this on your wall, and then you look at that instead of looking at your keyboard, you stop looking at your keyboard, and your different fingers are responsible for different keys, so you can type without looking. And make sure you learn your IDE features before you progress for both Android Studio, IntelliJ, or VS Code. There is nice IDE feature articles for Flutter. So thank you. That's all I have.
Thank you very much.
Welcome.
Thank you.
So async and await and all this asynchronous programming is kind of frustrating for beginners because it sounds like it's a hard topic to study, but it's actually not. And especially for those who are still studying in, so to speak, old school university program, which is more about procedural programming and so on. And it was back in the days where the whole concept of developing was based on the paradigm that user actually can wait. But then came mobile phones, then came the app stores with all those competitive applications that are trying to get seconds of your time just to promote itself and so on, when we kind of face the situation where user actually cannot wait and will not wait. And if you make user wait a little bit, you're gonna lose that user. Especially interesting since you mentioned that you are teaching game development as well, right? Because game development is kind of full of, mobile game development is full of all these async requests that have to fetch the data, all those pop-ups, all those statistics that are grabbing from different servers. And unless you understand that you should be using asynchronous programming in the particular game, you will not make the game that will keep a gamer's attention. Because in thread-heavy applications, user will not wait for sure. So our dear viewers, please consider that. Now we have a little bit of questions from the chat.
So yeah, in the meantime, maybe I can say, so we're doing game development in Unity, which doesn't have async await like this. It has coroutines, which is a little more difficult to use. And I cannot immediately teach students that because, you know, there's all kinds of boilerplate going around, IEnumerator, etc. They ask why, and they make all kinds of mistakes. So, but without that, it's very difficult to write the code for them. So they keep everything in class variables, etc. They try to keep state like that. It becomes very difficult. So it's a challenge. But I think in Flutter, with async await, it's very easy for newbies once they learn how to use it, compared to like something like Unity, which is a little more complicated to do async await, asynchronous code.
So Jamshid John asks about the difference between then and await.
Yes, no difference at all. As await is in the background, under the hood, it's actually doing a .then for you. So it's actually doing the .then for you. There's no performance difference. There's nothing different. But if you do await, then you can put a try catch around it. And you can have multiple awaits. You can have a big try catch around them. You can catch errors very nicely, very easily. With then, you have to have like a error, I forgot the name, error catching function that you have to put at the end. So with using .then and futures directly is more cumbersome. And you cannot do things like this. For example, you have an if. If it's true, I will do something that takes time. If it's false, I won't do anything that takes time. So you cannot do this with .then. But you can do this with async await. You can put in one branch, you can await. In another branch, you don't await. You do something synchronous. So there are things that are very difficult. Maybe you can do somehow, but very difficult to do with .then. But as far as what's actually happening in the computer goes, they are exactly the same, .then and await.
And what if the future response have to come in a certain time frame? I guess the case would be when the data that you are fetching is getting older, faster than you might fetch it.
So I didn't fully understand. Can you repeat?
So I want to, Jamshid John asks if he wants to wait a future response for a specific amount of time.
So future.delayed creates a future for you that completes after 3 seconds, for example. But if that's the question, yeah, you can just say future.delayed. For example, you want to just for fun make the user wait for 3 seconds. Just say future.delayed, and you get a future that will complete in that many seconds.
Yeah, well, it might be the case when the data you are grabbing from a server might get old in that 3 seconds. So if you wait longer, you don't need it anymore. And how to handle errors, also from Jamshid John.
Yeah, so try-catch works just like it does in synchronous code. The sequential code try-catch works exactly the same in await. You just put a try-catch around it. You don't care that there's an await inside, and it just works.
And it will not block the process, right?
Yeah, no, it's not going to block. So that's the beauty of it. You have a try-catch thing, and then you convert everything to async. It just works the same way, exactly the same way. You can even debug it line by line.
There was also a question by Ilhom, if JavaScript is also taught. I'm not sure about the context.
I was talking about the course that I had, mobile applications course at our university with React Native and Flutter. We spent a couple of weeks talking about both JavaScript and Dart. So that's what he was referring to. I teach some JavaScript there, but I leave it to the students to get better at it.
Okay. Thank you very much. Thank you very much
Thank you for having me.
Thank you.
Nice talking to you.
Yeah. And have a good day.
You too.
Bye.
So this is it about the...
So our next speaker, Ulukbek Israilov.
Yes, Ulukbek is joining us now, and
Hi.
please welcome.
Hi everyone, can you hear me? Check sound.
We have a Flutter heavy stream today.
Yeah,
so now we are going to talk about structuring the application, right?
Yep. Okay, hi everybody. I'm glad to be part of DevFest Central Asia. Hope you're all doing great. And in the next 30 minutes, we're going to have yet another talk about Flutter. So I'm going to share with you some lessons, tips that I have learned during my work with Flutter. So just a couple of words about me. My name is Ulukbek. I'm working with Flutter for the last 2 years, and I have created several Flutter apps for local and international market. So today we are going to talk about how to structure or architect your Flutter app, and we'll try to make our apps more maintainable and more predictable. This is our agenda for today. So first we will review some principles that every software engineer must know. Then I will give some practical tips in the context of Flutter development. And lastly, we'll take a look at a live example that I have prepared. So before we jump in, I should state that all I'm going to talk right now is fully based on my own experience. And disclaimer here, I'm not saying that, I'm not going to state that this is a bulletproof approach and you should definitely follow it bit by bit, but this is just general advices that I hope that everybody could find something useful in them. So without further ado, let's get started. Principles. I'm sure that everybody watching this stream today are familiar with Robert Martin or Uncle Bob, and who he is, what he have done. For those of you who still don't know about him, he is the guy who is responsible for these acronyms like dry, keys, solid, that everybody is asking in their job descriptions, right? So let's quickly recap some of them. Keys stands for keep it simple, stupid, which means that the code you are writing should be as simple as possible without any complexity. Dry means don't repeat yourself, which is self-explanatory. You should not have any code duplication. And lastly, let's mention single responsibility principle, which is a part of solid. And it basically means that every module, every class, or every function in your computer program should have only one responsibility and perform a single part of your program's functionality. If you don't know anything about these terms or about this topic, I strongly recommend you to do your own research, read about them, because these are some basics and fundamentals of software development. And if you want to be successful in IT in development, you should definitely understand and follow them. So principles are good, but how do I implement them in real app development, right? So our friendly Uncle Bob has helped here too when he proposed clean architecture approach. So what it is, it basically means that in the core of any system lies a business rules or business domain, which is actually true, isn't it? What we programmers do, we create programs for businesses, for business people, and usually business people, they don't really care what framework, what language we are using. as long as the program is working. And any other abstractions, languages, databases, or is it a web application or mobile application, everything is wrapped around this business rule. And if you, let's take an example of YouTube. YouTube is, today you can launch YouTube via your phone, tablet, laptop, or even on TV, right? And we are programmers, we all understand that they are talking with API to the same server, to the same backend. And backend doesn't really care what device is asking for a next video, right? And this is called decoupling or separating your UI and your business logic. This is what we should strive to in any application or system we are writing. Because at the end of the day, if we come back to Flutter, Flutter is only just a UI toolkit. It is used to create awesome, beautiful, full of animation UIs. And okay, enough theory. Let's move to some practical tips. The tip number 1 is use linter. What is linter, you may ask? And I will tell that linter is basically a tool that analyzes your code and draws red squiggly lines when you make some mistakes. I'm sure that you have seen it. And how can we use it? So we should use it. We can use packages, because linter rules are just another packages. We can go to pub.dev and find pedantic or effective Dart rules and add them to our pub-spec YAML. The next step is we should create analysis options YAML file in the root of our project and import there our pedantic package. So is that all? Well, yes and no. Here comes the best part, because if it was some existing project, you will most likely see something like this. Your IDE will have a lot of red lines, a lot of errors, and it will be literally screaming at you. So here comes the best part. You need to refactor everything. And you may ask, why do I need to make my life harder to follow these rules? Because these rules will ensure that the code you are writing follows Dart language style guidelines. And in some companies, these rules are enforced to obey. For example, pedantic package is used internally in Google. And don't get me wrong, they are actually not so hard, and you can easily follow them and make your code much cleaner and much type safe. And also, you can customize these rules, turn them on and off if you need, and you can read about it on dart.dev. So the next tip I'm going to give is use code generation. Dart has an awesome support for code generation, and you should definitely use it. So the best place to start with is JSON serialization. Any modern app today works with internet. It communicates with the internet through some API, and usually JSON files are used to communicate. So we need in our app to parse this JSON and create some models, right? And it is actually a lot of work, and it is very boring, monotonous, and you can easily make some typo, make some mistake, lose your type, which will further lead to some errors. So what is the solution? Solution is to use packages like JSON serializable or build value. So how can you use it? You just go to pub.dev again, import them to your project, follow instructions on the package page, and run this command. Run this command on your console: flutter pub run, build run or build, and let the Dart do its magic. We will take a look at the result of code generation in our live example. So the next tip I'm going to give is don't be obsessed by state management. And I put asterisks there for a reason. State management is a very much discussed topic in the Flutter community. everybody is arguing whether block is good, provider, Qubit, Mobix, Redux, etc., etc. Everybody is always arguing about it. But let's zoom out and apply our single responsibility principle for state management. At the end of the day, state management is responsible for managing the state of our app, right? Surprisingly. And we should not really depend on particular approach or on particular package, for example, on block or on provider, riverpod, and etc. We should structure our app in that way that we can easily replace one state management to another. For example, Qubit to block. And of course, you should. It always depends on the case. Not always you can use provider or riverpod, but we should strive to it, and we should select the state management wisely. And the last tip I'm going to give is create packages. So let's assume that you have an app with some image slider with cool animations. Also, you have some buttons with gradients. And in the next project you need to create the exact same slider or exact same button. So what you're going to do, I assume that you will open up your last project, copy all code, then paste it in your new project, then remove all dependencies, all references, change colors if you need. So sounds like a lot of work, right? So what I propose to you is you should create packages. You should encapsulate your widget, remove all dependencies, make it fully parameterized, and create a separate package. And you can reuse it in any new project you want. For example, I have a package for app lock screen with fingerprint support, and whenever in a new project I need to have app lock screen, I just import this package, and I'm ready to go. I just use app lock screen. I have it, let's say, for free. And don't limit yourself with just Flutter packages with widgets. You can create Dart extensions, only Dart code, and also reuse it. And if you feel that your package is addressing some common problem, common pain, you should definitely publish it on pub.dev so that everyone can use it. And this is how open source is working. So enough talking. Let's see the live example that I have prepared. Okay, let's first run our app. I'm using Flutter Web, so hopefully it will run. Yep. Now, this is our app that I have prepared. So you can click on this big button, and it will give you some ideas to do. For example, you are bored and you don't know what to do. So you just click on this button, and it will tell you what you can do. Also, we can choose some idea according to some category. For example, I want to do something social, right? And it will tell me go to concert with local artists with some friends, which we cannot do due to COVID and etc. etc. Right? So where is all this data coming from? I'm using Board API. This is the API that I'm using. This is its documentation. So it's basically dummy APIs that is giving us some data. And as you can see, my app is fully responsible. Yeah. So now let's take a look how it is done. So first things first, let's take a look at our analysis options.yaml that I have talked. This is all linter rules that I'm using. As you can see, we can turn on and off any options we want. But you can basically just include the pedantic package and you are ready to go. Also, we have assets. There could be some your images, fonts you can use. Then we can look at our lib, which is our main code, and main.dart. It's just running our app. This is our app. It's nothing rocket science. It's just material app with some title. And as you can see, we have some dependencies provider. Let's take a look. It's just a multi-block provider that I'm using to provide blocks of that will be used further in the widget tree inside my app. So here we can see folders core, home, and search. So let's take a look at core. What is core? When I'm creating apps, I use this core package to encapsulate all constants or themes, roads that are common, that are applicable to the whole app, right? And also widgets. For example, we have here adaptive text button, which can you see it's fully parameterized. We can give it text, on tab, color, and text color, and this is this button. Also, we have the loader. We can use this loader everywhere in our app, and therefore I put it in core folder. Here we have theme data, or all our theme can be stored here. Then for road management, for navigation, I'm using a package called AutoRouter. It also uses code generation. So as you can see, I just declare all my roads that I need, and then I run code generation, and it will output me this file with all of this code that I don't need to write. It's very useful, and you can use it. So here we have our root widget, which will be run when we start our app. And as you can see, we can use it for dynamic route. For example, for dynamic route change. For example, in our app, we need to show login screen when user is not logged in. And if he is logged in, we need to show his profile page, right? And here we can check if the user is logged in or not, and depending on the state, show him the appropriate page. Right now, we don't have this login or etc. That's why I'm just returning homepage. If we go to homepage is basically this screen, and we can see here several folders. Let's take a look from widgets. Widgets. These are some encapsulated widgets that I'm using. For example, this idea button widget is this big button with bulb. Then pages, this is the only page we have. So home page, this is the widget this is responsible for displaying homepage. This is just a scaffold with add bar, and then we have block builder, which builds the content of page depending on the state that we have. For example, if it's success, if it shows this title and controls, then if it's loading, it will show this loader. If it's failure, it will show failure, and etc. etc. So here are all contents, widgets that will display according to widgets that will display the content of page depending on what state is coming from our block. Here are some models that we are using. So it's just an idea model. This is it represents this string that is coming from our API. And the most interesting part is, of course, block that I'm using. I'm using block package from Felix Angelov, which is the most favorite block implementation. If we take a look to state, these are all states that can be in our homepage. It can be initial, loading, or success or failure, right? So initially, we don't have any tip. That's why it's called initial. Then we can have loading state or success state or failure state. And this state holds this idea model that we have to show this suggestion for our user who wants to do something. Then we have events. So we have just one event for this screen, which is on top of this big yellow button. It is called search random because we just search a random idea that we want to do. And the main file for block, which is where we map our events to state. So as you can see, we have only one event, which is search random. And when it comes to our block, what we are doing, we are yielding the loading state. As you can see, when we push this button, first it loads, right? It is loading. Then, if it's okay, if we got something, then we map this representation of activity to our idea model, and then we show it to our user through yielding. If some error happens, we catch it with our own exception. What is this repository doing, right? Because as I have told before, our block is responsible just to manage the state. That's why I encapsulated the logic of getting from API, getting data from API to the repository file. And we can take a look at it. But we cannot find it in the home folder, right? So where it is? It is in our packages folder. It is fully encapsulated, and therefore I created a separate package for it. As you can see, we have a board repository package, and it has its own analysis options, its own pubspec YAML. So if we take a look at its file, so it has a bunch of methods like get random or get by type, which we use when we want to get for some particular category of actions that we can do. And there are a lot of other methods that we can use, for example, of that activity or according to some accessibility level. And again, if we take a look at its implementation, it is calling some API client and expecting some exception, or if there is no any exception, it will just return the activity. So again, I just encapsulated the logic of getting data from API client to its own class. If we take a look, we have board API folder, and we have its own model here. It uses JSON serializable, and I just declared all properties that activity can have. Where do I get it? I get it from the documentation of API. As you can see, these are all properties that can come to me from API. So I just declared them and run my code generation, and this is what code was generated. It is fully type safe, and therefore I don't need to think about if I will have some exceptions, some errors with the types. And this is the implementation of HTTP GET call. So I'm just throwing some parameters that can be used to get exact activity that I want. For example, we can get it by key or by type, and etc., etc. So these are all parameters that can be used. As you can see, we encapsulated our API client and our repository to its own package, so that we don't really care where the data is coming. For example, right now it's coming from API, but further it can come from our local storage, from our database. So what we should do, we just need to change all the logic inside this board API package, and the rest of our app we can just don't touch it, and it will work as expected, because we successfully separated all our UI and our business logic and our calls to API, calls to local storage, and etc. So that's all from my side. I will thanks to everyone who joined this talk. these are some. These are my Telegram account and GitHub account. You can reach me if you have any questions. Also, we have some Flutter Uzbekistan community. You can also join there and post your questions and talk, and have a good day. Thanks.
Thanks.
Thank you very much.
We have some questions.
Yes.
Yes. So first,
Okay. Can you explain briefly? Okay, scoped model is one of the first state management approaches that was proposed by Google, but right now they are proposing to use provider with change notifiers, which is basically just evolutionary step, one step further from scoped model. And as I have told, block, scoped model, provider, qubit, and etc., they are all used for managing state. They are all state managements. And architecture is more abstract thing. It's how you structure your app. It's how the data flows in your app. So when you're choosing the state management approach, you should first look in your domain, how big will your app be, and how many people will work on it. Yeah.
Thank you. And
Is
how
it
about mixed solution?
And block as a mixed solution for? Yeah, why not? You can definitely mix them, but make sure that they are separate. They are separated. Then there will be no mess eventually in your code, because it's very easy to make a mess, and then nobody except you will understand your code. That's why it's better to just and stick with it inside the context of one project, so that anybody who will work with you or after you continue your work.
As Robert Martin said, we are expecting developers to provide good code. So good code also means readable code, not just working code. So keep that in mind.
Yeah.
Also from Jamshedjon.
Courses say not to use state inside the widgets, since it may cause problems, but it's simple for me for creating a fast program. Well, yes, set state, you can use it for creating fast prototypes, for just testing your idea, but set state is not scalable. So it's better to, as I have told, the whole idea is to separate your UI and your business logic, because Flutter is responsible for UI. So your widgets, what you should strive to is that your widgets are as dumb as possible. They should not know how the data is coming, where the data is coming from. The best is that you just give it the data and it shows it, and it just makes some actions in the form of sending events. So set state is okay for small projects, for one-page projects, for just testing your idea, but it's much better to use some approach, some state management techniques. So definitely do your research and read about it.
I also have to thank Jamshedjon for having such a good participation in questions both today and yesterday. So thank you, Jamshedjon. And question from Islam about how to use block.
Do you use block per page or per widget? Well, it always depends. For example, if you have some widget that has a lot of logic with it, for example, some image slider, right? It should load images from internet or from or locally from your database from SQLite. And in this case, you can make a block exactly for your widget, for your image slider. But mostly what you will do is you will create blog for use case, not for page even, but for your use case. As we saw in our live example, we have a use case of searching an idea. So this use case is responsible for getting the data from API, showing the loading state, showing failures, and our page can change, but the idea, the use case is the same always.
Okay, thank you. And I guess the last question would be about using getXlib.
What do you think about getX? Yeah, getX is a relatively new package. I also saw it like 2 weeks ago, and it's getting popular. But I can say that it's a lot of mixtures there. There is a mixture of state management and dependency injection. So you better keep it in mind so that you will eventually don't have a mess. So as I have told, your widgets, they must be dumb as possible. They should not know anything about domain, about your logic. When you create your applications in this way, you will eventually have a very scalable and maintainable app.
So,
getX is good. Keep it in mind.
So it's enough stable to use in big projects and go to release.
Yeah, of course, you can use it in big projects, but always be aware of the consequences when you depend on packages like this. When you depend, when your logic all your logic depends on one package. For example, if this package will not be maintained anymore, what will you do? You need to think about these cases also.
Well, thank you very much, Lukbek. It was a pleasure having you.
Thanks for having me.
Have a good day.
You too.
And our next speaker for today is Alexander Denisov from EPAM.
Привет,
Hello,
привет.
how are you?
Привет.
Hello.
Да. Последний семинар у нас, возможно задавать вопросы на русском языке. Рада вас видеть, спасибо, что присоединились. Воскресный день.
Да, я тоже очень рад к вам присоединиться. Я, конечно, мог бы и на английском рассказать, но я думаю, что на русском будет, наверное, проще и понятнее.
Как вам удобнее?
Хорошо.
Спасибо.
Тогда давайте я приступлю. Вот. Меня зовут Александр Денисов. Я работаю в компании EPAM Systems, живу в Москве и уже достаточно большое количество времени являюсь Flutter-разработчиком. Ну, собственно, да, пишу на Flutter. Вот. Но, кроме того, я еще Flutter GD, Google Developer Expert. Вот. И тоже занимаюсь организацией Google Developers Group, только в Москве, организатор GDG Moscow. Вот. И по поводу этого доклада, то есть на самом деле про Flutter много где и много как сейчас рассказывают. Вот. Но я обратил внимание, что большая часть рассказов, которые сейчас происходят, она в основном касается каких-то best practices, каких-то вопросов, связанных с архитектурой, да, что лучше использовать, там, блок или Redux, как это отличается от Scoped Model, ну и тому подобное, в общем, best practices. И достаточно мало докладов, которые рассказывают нам о том, как же вот так это происходит, что мы пишем какой-то код, вот, описываем какие-то виджеты, потом происходит какая-то магия, и мы на экране телефона видим какое-то приложение. Да? А как же это происходит там, под капотом, внутри? Ну и, собственно, это и была идея вот этого доклада. То есть мы не будем здесь рассматривать какие-то конкретные примеры кода, какие-то best practices, а просто пытаемся разобраться, как же вот это все работает. Вот. Ну, начну издалека. Как Flutter – это такой фреймворк, который позволяет нам создавать beautiful, fast, productive, open приложение. Ну, что здесь имеется в виду, да? Beautiful – это значит, что у нас там есть возможность создавать beautiful UX, используя способы управления чуть ли не каждым пикселем. Fast – это значит, наше приложение работает быстро, потому что использует там скию под капотом и рисует виджеты само по себе. Productive – это мы можем делать приложение быстро, потому что у нас есть такие классные штуки, как hot reload, hot restart, одновременный дебагинг на нескольких устройствах и так далее. Ну и open – это все open source, мы можем посмотреть исходный код и так далее. Обычно вот так начинаются доклады о том, что же такое Flutter. И еще вот обычно прикладывают такие классные гифки с примерами super flexible UI, красивыми картинками и так далее. Ну, в общем, я подумал, действительно, сколько уже можно про это говорить. Давайте проговорим про кишки. Вот такую картинку, наверное, большая часть из вас, кто интересовался Flutter, видели большое количество раз, потому что, ну, собственно, с нее и начинаются рассказы о том, что такое Flutter. Вот. Но на самом деле она не совсем полная, да. Тут можно добавить еще одну часть платформенную. То есть верхняя зелененькая часть – это у нас фреймворк, написанный на Dart, который мы можем там по команд-клику пройти и посмотреть имплементацию любого нашего виджета и так далее. Синенькая – это уже Dart Engine, Flutter Engine, написанный на плюсах, который уже гораздо похитрее, и там происходит много магии. Там внутри находится как раз Skia, вот, внутри находится виртуальная машина Dart, вот, текстовый engine, еще много чего. Ну и нельзя обойтись без платформенной части. Платформенная часть – это как раз та часть, которая отвечает на взаимодействие Flutter и платформы. Да? Потому что Flutter же он один, платформ много. Вот. И как же ему там запускаться на ней. Да? Поэтому на Android есть свой Android Shell, который позволяет Flutter запускать в качестве отдельной activity. Да? Там на iOS есть iOS Shell, вот. Для всяких embedding устройств есть Embedder API, вот. Для веба есть своя отдельная веб-штука, ну и так далее. Вот. То есть эта часть, она разная для каждой платформы. Ее обычно почему-то забывают. Вот. Ну и Flutter-разработчик, как правило, во время своей работы большая часть работает только вот с этой маленькой частью фреймворка, да? Ну, потому что здесь как раз находятся виджеты, а что мы делаем? Да? Мы просто берем и создаем эти виджеты, чтобы получить наш UI. Вот, поэтому у нас есть какие-то готовые блоки, которые мы просто берем и используем. Собственно, и в этом так получается наша программа. Вот. Давайте мы попробуем заглянуть поглубже, пониже, поскольку у нас это слоистая, да, архитектура, попробуем заглянуть пониже. Ну, вот эту картинку, наверное, тоже большая часть из вас видела, да, это то, что все виджеты во Flutter, everything is a widget, да, и все виджеты во Flutter делятся на два типа, там, stateful и stateless. И, по сути, когда мы пишем свой код, мы просто берем и компонуем дерево из этих виджетов. Дерево. Почему дерево? Ну, посмотрим, да, самая простая, там, simple программа на Flutter, да. У нас есть material app виджет, в который мы вставили scaffold. Вот. Внутри scaffold у нас есть app-бар для отображения там, в верхней панельке. Да, в ней есть какой-то текст. Вот. Ну, а уже в теле scaffold у нас есть виджет-центр, в который мы поместили столбец с двумя строками текста. Вот. Ну и вниз floating action button, кнопочка для того, чтобы совершать какой-то экшен, и в нее, значит, ставим иконку. Вот. Вот это, собственно, здесь нарисовано как раз виджет 3. Вот. Давайте посмотрим, похоже на дерево? Ну, вроде немного похоже даже, да? Но дерево же растет от корня, а у нас в корне material app. Так вот, если дерево перевернуть, посмотрим. Ну вот, вроде дерево. Ну, вот так выглядит экран телефона с запущенной программой, которую мы только что обсудили, да, вот как раз Material App. внутри scaffold, и там есть abbar с текстом, и столбец с 2 строчками и кнопка. Вот. То есть у нас было какое-то дерево с какими-то виджетами, и получился экран. А что же, собственно, из себя представляют эти виджеты, да, из которых мы дерево компонуем? Вот. Если заглянуть в исходный код, вот, и посмотреть код виджета, то здесь такой верхний кусочек определения виджета. Что мы в первую очередь видим? Да? Видим аннотацию immutable. А что значит immutable? Это значит, что все поля этого класса final и не могут быть изменены. Ну, как же так получается, да? То есть у нас, с одной стороны, там классный UI-чик, который у нас мы что-то делаем, что-то меняется, да, вот все это происходит, да, а у нас immutable, и вроде как бы все должно быть статично. Что-то не складывается, да. Вот. Ну, и если поразмыслить, да, таким образом, то можно сделать вывод, что на самом деле то, что мы видим на экране, это, конечно, не виджеты, потому что виджеты immutable. Значит, есть какие-то еще объекты во Flutter, которые, собственно, рисуют что-то на экране. Вот. И можно сделать вывод, опять же, да, что виджет – это же, по сути, просто конфигурация чего-то. Мы что-то конфигурируем. Вот. А это просто статическая конфигурация, которая один раз нам что-то конфигурирует, и это что-то потом рисует нам уже на экране. И да, это действительно так. Во Flutter существует не одно дерево виджетов, а на самом деле там 3 дерева. Есть еще дерево элементов и дерево рендер-объектов. Вот. И за что они отвечают? Дерево виджетов действительно отвечает за конфигурацию. Дерево элементов отвечает за жизненный цикл. Ну, собственно, элементы – это и есть те главные объекты, которые всем управляют. Они управляют жизненным циклом этих компонентов, видимых на экране. Ну и есть еще отрисовка. За отрисовку отвечает дерево рендер-объектов. Ну, то есть, например, мы запрограммировали, закодили какой-то виджет. Вот. И когда у нас исполняется наш код, вот, то как бы Flutter смотрит, ага, вот у нас есть виджет. А есть ли у этого виджета соответствующий ему элемент? Если элемента нет, то элемент создается. И после этого связывается с этим виджетом. Ну, то есть, заметьте, да, элемент связывается с виджетом, а не виджет с элементом. Потому что элемент главный, а виджет всего лишь его конфигурация. Вот. После этого элемент создает рендер-объект, который будет, в свою очередь, уже что-то рисовать на экране. Элемент, он просто управляет этим всем. Вот. Ну, а если у нас дерево виджетов, то ему соответствует дерево элементов, и ему соответствует дерево рендер-объектов. То есть каждый элемент привязан к своему виджету, чтобы брать эту конфигурацию, и привязан к своему рендер-объекту, чтобы управлять отрисовкой. Причем, как видите, да, не у каждого элемента есть свой рендер-объект. Почему так? Ну, потому что не каждый объект должен быть отрисован. Смотрите, взять, например, какой-нибудь layout. Ну, layout все-таки имеет рендер-объект, на самом деле, если быть честным, потому что он тоже управляет размером. А вот если взять, например, stateless widget, это ведь тоже виджет, но, по сути, он просто в методе build объединяет несколько виджетов, которые будут рисоваться. Вот. Это называется компонентный виджет, которому соответствует компонентный элемент, и он, на самом деле, ничего не рисует, он просто объединяет. Вот у такого элемента не будет рендер-объекта. То есть, поскольку есть виджеты, которые что-то прямо рисуют, типа текст, image, там, button. Есть виджеты, которые их компонуют. Это stateless widget, stateful widget. Вот. Им, соответственно, компонентный элемент, который не рисует ничего. Вот. Но есть еще третий тип виджетов, который тоже ничего не рисует. Это inherited widget, но о них еще потом отдельно поговорим. Это виджеты, которые, соответственно, прокси-элементы, которые прокидывают какие-то данные вниз по дереву. Ну и если посмотреть на рендер-объекты, то это как раз дерево, которое мы и видим на экране. То есть мы видим не виджеты, не элементы, мы видим рендер-объекты. То есть всему экрану соответствует некий рендер-вью, вот, и внутри этого рендер-вью у нас располагаются рендер-объекты как элементы дерева один над другим. Вот. И они уже управляют своими размерами, своим там, цветом, содержимым и так далее. Вот. Давайте посмотрим поведение простого виджета. Вот. Пускай это будет виджет текст. Вот где-то у нас в дереве, значит, есть виджет текст. Вот. У нас происходит первый прогон по дереву виджетов. На виджету текст создается и ставится ему в соответствие текстовый элемент. Потом по этому текстовому элементу создается текст-рендер, который будет его рендерить. А потом мы решили этот текст поменять. Ну, потому что там, не знаю, пришло другое состояние, да, нам надпись надо поменять на экране. Вот. А мы помним, что виджет иммутабельный. И поэтому у нас не меняется текст внутри виджета. У нас просто уничтожается тот виджет, который был, и взамен ему ставится другой виджет, новый, свежий. Именно поэтому говорят, что... Ну, не именно поэтому. Вот говорят, что дартовский garbage collector очень подходит для работы с Flutter, да, потому что как раз у него очень хорошо получается быстро уничтожать цепочки объектов, потому что бывает, что целые деревья надо перестраивать, и надо уничтожить одну цепочку виджетов и создать другую. Garbage collector очень хорошо с ним справляется. Ну так вот, у нас появился новый виджет, и после этого надо поставить ему в соответствие элемент. Вот смотрится на том месте, где раньше стоял элемент, того виджета стоит этот элемент. И происходит проверка. А соответствует ли новый виджет старому элементу? Проверка, причем производится по двум параметрам. Это по типу виджета и по его ключу. Ну, соответственно, отсутствие ключа – это как бы тоже ключ, только если ключа нет, то значит только по типу. И вот если тип соответствует и ключ соответствует, то они связываются. И старый элемент привязывается к новому виджету. Вот, то есть элементы, они мутабельны, и они создаются, ну, поскольку это объект значительно более тяжелый, чем виджет, вот, они по возможности стараются не быть пересозданными, а просто измененными. Итак, старый элемент привязывается к новому виджету, а после этого проверяет, не надо ли что-то поменять в рендер-объекте. Смотрит конфигурацию, свой виджет. Текст изменился. Значит, меняем текст в рендер-объекте. Вот. И при следующем построении фрейма текст на экране будет изменен. Как вообще Flutter понимает, да, что нужно какие-то виджеты ребилднуть, а какие-то, может быть, не ребилдить? Что надо проверить, надо что-то менять в рендер-объекте или нет? Для этого есть такое замечательное свойство, называется dirty, грязненький, запачканный. И у нас, когда идет прогон по дереву элементов, для того, чтобы посмотреть, надо ли что-то перерисовывать и перебилдивать, он проверяет состояние. И если элемент не dirty, то все окей, идем к следующему. А если элемент dirty, то значит надо ребилднуть виджет, получить новую конфигурацию и проверить ее соответствие, ну, то есть насколько конфигурация соответствует тому, что есть в рендер-объекте, надо ли там что-то поменять. Вот. И именно поэтому Flutter тоже так быстро работает, то есть ему не надо каждый раз ребилдить все виджеты. Вот. Он ребилдит только те, которые действительно нужно изменить. Вот. И одна из причин, да, почему нам не рекомендуют делать большие методы build. Потому что если у нас изменилась какая-то маленькая часть, вот, то весь элемент, который соответствует этому виджету, помечается как dirty. И, соответственно, вызовется весь билд, и как бы все операции внутри него будут выполнены. Вот. А если виджеты сделать поменьше, то, соответственно, билд вызовется только у того, который действительно изменился. И, соответственно, перерисовываться будет только тот рендер-объект, который соответствует ему. Вот. А все остальные, ну, там с рендер-объектом чуть сложнее, но суть в том, что вызовется только один билд, а не все остальные, как если бы их запихать внутрь большого билда. Вот. Ну, и тут еще нужно посмотреть на сами виджеты, то есть как происходит установка этого свойства dirty. Ну, то есть есть stateless виджет, он там простой как палка, да, у него есть конструктор и метод build. Вот. И каждый раз, когда происходит какое-то изменение, у него там в паренте, который его создает, он просто уничтожается и пересоздается. Вот. И, соответственно, когда он пересоздается, его элемент выставляется в dirty. Вот. Со stateful виджетом все немножко сложнее, поскольку сам stateful виджет состоит из двух элементов. Из иммутабельного виджета, в котором есть всего два, ну, как бы тоже два метода, да, есть конструктор и create state. Вот. Причем create state реально создает state только первый раз. Вот. Ну, и есть state, у которого большой и хитрый lifecycle. Вот. И в случае stateful виджета на самом деле маунтится с элементом не сам виджет, а именно его state. Вот. И state иммутабельный. То есть он не пересоздается каждый раз, он может быть изменен. И как раз тут очень важно понимать, да, когда state у нас изменился и когда нужно произвести какие-то изменения в дереве. Давайте посмотрим на его lifecycle. Сначала, после того, как state создается первый раз, у него вызывается метод initState. Причем initState вызывается тоже только один раз при создании. Вот когда инициализируются какие-то основные свойства state и тому подобные вещи. После initState сразу вызывается didChangeDependencies. Этот метод вызывается не только при создании, не только сразу после initState, вот, но каждый раз, когда изменяются какие-то зависимости виджета, зависимости в дереве. То есть, если у нас виджет, например, имеет зависимости через inherited виджет где-то сверху, там, от какого-нибудь провайдера, там, и использует внутри из контекста ссылку там, на media query, еще на какой-нибудь inherited виджет, да, то в этом случае вызывается didChangeDependencies, и оно ставит элемент в dirty всегда. То есть, если какие-то зависимости изменились, то нужно виджет ребилднуть и перерисовать. Вот. Кроме того, есть еще два способа, как сделать элемент у стейта dirty. Это didUpdate виджет. Этот метод вызывается каждый раз, когда виджет этого стейта поменял какие-то свои свойства, то есть которые мы получаем в стейте через поле виджет. Когда это что-то меняется, то у нас вызывается didUpdate виджет, и он тоже ставит state в dirty. Вот. Мы можем там ставить какие-то дополнительные свои элементы для переопределения. Вот, для того, чтобы анимацию какую-нибудь перезапустить или еще что-нибудь. И, конечно, тот способ, который все знают, это метод setState. Что делает setState? Он просто прямо руками помечает элемент этого стейта как dirty и говорит: ага, следующий прогон перерисуй меня. Вот. И поэтому, если мы, например, забыли вызвать setState, когда поменяли какое-то свойство этого стейта, у нас на экране нет никаких изменений. Потому что мы не сказали, что эти изменения нужно притянуть на экране. А когда мы делаем setState, мы говорим: все, элемент dirty, в следующий раз ребилдни ее и возьми конфигурацию для отрисовки. Вот. Каждый раз после метода build элемент помечается как clean, и значит все, больше в следующий раз мы его не ребилдим, а используем as is, как есть. Вот. Ну и как бы следующий вызов setState, didUpdate виджета или didChangeDependencies помечает его опять как dirty, и он опять билдится. Вот. Ну тут есть еще пару методов deactivate и dispose. Deactivate вызывается каждый раз, когда у нас этот state выходит из дерева, когда он подменяется каким-то другим элементом, вот, но сразу не уничтожается, потому что, возможно, в ближайшее время он опять должен будет вернуться в дерево, или, например, он будет вызван в каком-то другом месте и переиспользован и так далее. Ну, а dispose – это уже когда виджет окончательно выкидывается и уничтожается. Вот. Давайте посмотрим на такое более сложное поведение, как это реально происходит. Вот у нас есть, например, какой-то виджет, который внутри состоит из центра, кнопки и текста. Ну, то есть виджет-центр, который внутри себя держит кнопку, то есть он помещает себя в центр своего парента, внутри себя рисует кнопку, ну, а в кнопке у нас написан текст какой-то. Ну, соответственно, при первом вызове на соответствие им ставятся элементы. Центр элемент, button элемент, текст элемент. Ну и потом эти элементы создают рендер-объекты. Центр рендер, button render, текст рендер. Ну и поехали. У нас меняется текст по каким-то причинам, неважно по каким там. Это пришло через inherited widget, это пришло из парента, там, whatever, как-либо. Вот. Значит, виджет текст у нас должен уничтожиться и замениться другим. Вот. Но поскольку у нас все это внутри одного виджета, то он должен весь пересоздаться. Вот. И поэтому, когда идут проверки, проверяют новый центр, проверяем, а центр не изменился. То есть у нас тот же тип, тот же ключ, вот, и вообще изменений никаких нет. Поэтому оставляем все как есть. Button. Button вроде тоже не изменилось, тот же самый ключ, тот же самый тип. Вот, проверяем на соответствие, изменилось ли что-то в рендер-объекте. Ну, с первого взгляда вроде не изменилось, да, тот же виджет, тот же тип и никакого содержимого вроде нет, но на самом деле есть. Там же внутри же есть виджет-текст, который поменялся и изменился. Сейчас тут подробнее про тому, как это происходит в дереве render-объект расскажу. Пока просто запомним, да, что он должен будет перестроиться. И вот текст. У нас новый виджет, проверяется по типу, по ключу. Вот. Надо поменять в дереве рендер-объектов текст. Текст меняется. Вот. Ну, а как на самом деле происходит работа в дереве рендер-объектов? То есть проход по дереву рендер-объектов на самом деле происходит 2 раза. Первый раз вместе с проходом по дереву элементов, когда мы отмечаем, что действительно поменялась конфигурация, а что нет. Вот. Но потом происходит второй прогон снизу вверх. То есть мы прошли и поменяли первый раз на самом деле только текст-рендер. Но потом текст-рендер говорит вверх по дереву, во мне изменился текст, и значит, на самом деле изменились мои размеры. И он передает измененные размеры вверх по дереву. И меняется button рендер, потому что текст другой длины, и там кнопку под нее надо подстроить, ну, в зависимости от, как она сделана. Вот. То есть, когда происходит проход по дереву рендер-объектов, то сначала верхний рендер-объект спускает вниз свои констрейнты, следующий спускает свои констрейнты вниз, и так до самого последнего рендер-объекта. А тот уже рассчитывает свои размеры и передает обратно вверх. В твоих констрейнтах мне нужны такие-то размеры. Тот говорит, ага, понял. Вот, и ты убираешься, все, окей. Значит, мне нужны, значит, такие размеры с учетом твоих размеров. И передает их обратно вверх. И вот после этих 2 прогонов у нас создается так называемый фрейм, который состоит из рендер-объектов, которые уже знают, где они находятся на экране, в каких местах, с какими размерами и так далее. Вот. А что если у нас мы решили не поменять текст, а вообще текст убрать и вместо него поставить иконку? Оп. Ну, происходит на самом деле плюс-минус то же самое сначала. Ну, вот здесь все так же, мы сверяем по типу, все так же, как в прошлый раз. Ну, что-то поменялось, что-то не поменялось. И вот тут иконка ищет в соответствии себе элемент. И не находит его, потому что его нет, потому что там элемент для текста. Вот. В этом случае создается новый icon-элемент, вот. А предыдущий элемент деактивируется. Он пока остается в памяти, но открепляется от активного дерева и пока там просто висит. И если в ближайшее время к нему не обратятся, заново перестроить, то он уже будет диспожен и выкинут напрочь. Вот. Соответственно, создается новый рендер-объект взамен того, тот тоже уничтожается, и уже перестраивается все дерево. И тут еще интересный момент, да, если мы посмотрим в код элемента, Вот. Что же такое наш элемент? Да? То можно увидеть забавную вещь вот в конце верхней строчки, что элемент имплементирует класс интерфейс buildContext. И там, если покопаться и подумать, то на самом деле очень легко делается вывод, что вот тот самый buildContext, который мы получаем в методе build и который везде используем для того, чтобы вытащить там значение inherited widget и так далее, это не что иное, как ссылка на элемент, соответствующий этому виджету. То есть контекст – это та дверка из дерева виджетов к дереву элементов. И вся информация, на самом деле, которую мы получаем о размерах других виджетов, информация об inherited виджетах и так далее, мы получаем через дерево элементов, когда через контекст мы обращаемся к нему, и из дерева элементов все вытаскиваем. Вот, потому что виджеты ничего на самом деле не передают, кроме своих параметров. Вот, а все взаимодействия с контекстом – это на самом деле взаимодействие с деревом элементов. И это дает ответ на один из вопросов, который часто бывает задают на собеседовании. Да, например, вот build-контекст, который мы получаем в методах build у разных виджетов, это один и тот же контекст или разный? Ответ – разный, потому что в каждом билде build-контекст – это ссылка на элемент этого виджета. Но поскольку дерево виджетов, оно связано между собой, то через этот контекст мы можем получить информацию об элементах выше по дереву и, соответственно, об их рендер-объектах. Вот. Ну, а все-таки, если... Ну, да, даже не так сейчас, как скажу. Вот мы немножко должны были поговорить о том, как происходит рендеринг, пейнтинг, gestures and foundation, но на самом деле просто поговорили, как у нас устроены деревья внутри. Вот. И чтобы смотреть дальше вглубь, как происходит вообще процесс рендеринга и пейнтинга, ну, можно эту картинку немножко изменить. Вот. На самом деле вот так вот можно сделать, да? Потому что engine обычно рисует очень сокращенно, да, на самом деле в нем тоже очень много частей, вот, и платформ содержит тоже очень много элементов, которые платформ-специфик для каждой из платформ. Вот. Начнем просто издалека, как все это происходит. Если посмотреть на вот эту часть, например, Event Loop Interop. Что это за часть? Это часть платформенного куска движка, который отвечает за связь событий, происходящих на платформе, с, собственно, фреймворком. Вот. А почему Event Loop? Вот. Ну, потому что, наверное, читали, знаете, да, что в Dart все происходит внутри Event Loop, что вот этот один поток дартово исполняемого кода у нас сначала исполняется метод main, а потом все события, которые происходят в нашей программе, да, они просто ставят события в Event Loop и по очереди исполняются. Пока исполняется одно событие, ну, исполняется один кусочек кода, один ивент, у нас не могут исполняться другие. И вот Event Loop Interop как раз отвечает за то, чтобы перехватывать события платформы и вставлять их в наш Event Loop. То есть у нас тапнули на экран, событие о том, что тапнул экран, вставляется в Event Loop, что надо это отработать. Вот. У нас там сработал таймер, у нас еще что-то произошло. Вот. Это все ставится в Event Queue в очередь и обрабатывается. Вот. И когда событие о том, что у нас что-то произошло и нам нужно это обработать и отрисовать, оно уже прокидывается через Event Loop Interop, получается, и начинает обрабатываться, собственно, движком. Вот. Давайте посмотрим, как это происходит. Произошел какой-то external event. Движок понимает, нужно заскедулить фрейм, чтобы отрисовать, ну, обработать и отрисовать, что же изменилось. Вот. У нас закидывается все это дело в Event Loop и запускается процесс формирования фрейма. Вот. Сначала отрабатывает метод BeginFrame, который, собственно, его формирует, а потом drawFrame, который начинает его формировать. И вот он уже связывается с фреймворком, который сначала запускает билд дерева виджетов, вот, на основе которого формирует layout через дерево элементов. И после этого формируется как бы фрейм из рендер-объектов, и запускается painting, который рисует его, вызывая метод renderSki из engine. Вот. Потом еще есть postframe. Это callback, который вызывает после того, как фрейм сформировался. Мы можем его вызвать, например, написав где-нибудь в init state, там, postframe callback запустить, там, еще что-нибудь. Потому что если нам нужна какая-то информация об уже отрисованном виджете, там, не знаю, размеры, которые мы не знаем до того, как стартанули отрисовку, вот, то до того, как он отрисуется, мы их не знаем. Но мы можем посмотреть в постфрейме. Вот для этого мы делаем postframe callback, который запускается после отрисовки и может сделать, ну, провести какие-то расчеты и заскедулить, например, новый фрейм измененный. А как работают анимации? Ну, анимации на самом деле работают очень просто. Есть некий объект тикер, который отслеживает, что анимация должна изменяться при состоянии каждого фрейма. И вот этот begin frame, перед тем, как стартануть draw frame, он вызывает все тикеры и говорит им: подвиньтесь на один шажочек. Тикеры двигаются, и все animation контроллеры и прочие виджеты, которые формируются на основе анимаций, они двигают тикеры, и все анимации чуть-чуть изменяются. И при билде учитывается уже следующее состояние этих анимаций. Вот. Но там еще много всяких квадратиков, да, мы так как-то по разным кускам попрыгали. Вот. Давайте посмотрим какие-нибудь еще квадратики. Thread setup. Thread, поток. Но вроде Dart однопоточный, да? Все слышали. Ну, там, что можно изолейты делать, это тоже все знают, да, но thread это вроде не изолейт ни разу, да. На самом деле, даже при том, что Dart однопоточный, Flutter не однопоточный. Flutter работает в 4 потоках, вот. И эти потоки на разных платформах формируются по-разному. Есть некий такой thread-хост флаттеровский, вот, который управляет этими тредами, и на каждой платформе их 4. Ну, там с вебом чуть по-другому все работает, поэтому веб вообще отдельно. Мы говорим о платформах, в которых есть какая-то нативная часть, да? Вот, веб пока не трогаем. Вот. Есть платформный тред, в котором, соответственно, происходит взаимодействие с самой платформой. Вот там мы перехватываем события платформы, вот, там мы говорим платформе, как рисовать, вот, там мы запускаем там какие-то платформенные задачи, через него связываемся с платформ channel, через него работает и так далее. Есть UI-thread, это UI-ный поток. Вот в UI-ном потоке происходит все, что делаем мы. Наш код исполняется в UI-ном потоке. Все изолейты запускаются в UI-ном потоке. Вот. Методы build, ну, вообще весь наш дартовый код запускается в UI-ном потоке. Вот. И мы, кроме UI-ного потока, ничего не видим. Все остальное управляется платформой. Поэтому у нас как бы тоже только один поток. Вот. Есть еще GPU-thread. Вот в нем работает Skia, и она рассчитывает там графику в нем, чтобы перед тем, как рисовать. Вот. И есть последний IO-thread. Он используется для того, чтобы не отвлекать GPU и Skia от того, что пересчитывать реальные размеры. То есть, например, если нам прилетела картинка размера 1000 на 1000, а нам надо нарисовать ее 100 на 100, вот. Если мы будем это в GPU-потоке делать, то мы поток будем тормозить. И поэтому он в отдельном потоке перерасчитывает размеры этой картинки для того, который нам нужен, и подсовывает GPU уже в правильных размерах, чтобы она не отвлекалась, а просто рисовала. Вот. То есть такой не очень много на себя берущий поток, но постоянно загруженный, потому что у нас вечно размеры не те, которые нам нужно отрисовать, поскольку у нас же мы рисуем всегда под разные типы экрана, можем перестраивать, вот он всегда нам подстраивает наши картинки. Вот, ну, такое, да, тут надо нормально разбираться, как это работает внутри. Вот. Что еще? Render Surface Setup. Что это такое? Skia. Skia – это кроссплатформенная штука, которая рисует нам 2D-графику. Но как она понимает, на чем рисовать, да, поскольку у каждой платформы какие-то разные свойства, разные средства для отрисовки внутри себя. Вот. Ну, и вот как раз Render Surface Setup занимается тем, что берет у платформы информацию о Surface, на котором ски надо рисовать, и представляет его ски. Вот. То есть, например, в Android это есть Android Surface, вот, который через OpenGL, ну, как бы ски использует OpenGL при работе с Android, и вот через Surface связывается. В iOS, например, аж две. То есть, по-старому это OpenGL, и по-новому, вот, начиная от начала с этого года, Flutter поддерживает Metal. Вот. И включая или выключая поддержку Metal, мы говорим вот этому Render Surface Setup, какой Surface предоставлять ски, OpenGL или Metal-ский. Вот. Это настройками при билде все это может регулироваться. Я на самом деле веб сюда тоже засунул, хотя там в вебе все по-другому, похитрее работает. Вот. Но у веба есть тоже два способа отрисовки, вот. И только один из них использует ски. Вот этот дом Canvas, который первый, он на самом деле ски вообще не использует. Он использует средства веба, и Canvas API, и дом. Ски не задействовано. За счет этого там все медленнее работает, и есть там определенные сложности. Вот. И есть новый способ, называется Canvas Kit, который через WebAssembly прокидывает ски, вот, и использует WebGL для отрисовки. Но в этом случае у нас получается вообще совсем не веб-страничка, а прям вообще приложение запущено, потому что он просто рисует. То есть там текст, не текст, там нарисованный виджет текст. Вот, то есть там все будет происходить так же, как и в обычном приложении. Вот, но она еще более сырая. Ну, тоже запускается отдельный пропертёй при сборке веб-приложения. Но там пока часто падает. Но они активно работают, ну, они, в смысле, Google, разработчики. Вот, и, возможно, это будет скоро основной способ для работы с вебом. Вот, ну, и, например, Flutter также работает с фуксией, да, и там есть свой Surface-сценик на основе вулкана, который тоже предоставляется ски. И то есть вот сам синенький Flutter Engine, ему вообще по барабану, где рисовать. Ему просто Surface предоставляется, и он на нем рисует. А вот Render Surface Setup этот Surface предоставляет. И там много, на самом деле, всех интересных штук. Вот, у нас, если бы я пытался все их запихать в доклад, то мы бы не убрались пару часов. Давайте посмотрим, что еще найти в плагинс. А вот здесь хватит уже, да. Как я сказал, если мы сейчас про все начнем говорить, то мы можем до завтра говорить. Это время уже вечернее. Ну, тут в Москве еще не совсем вечернее, но у вас уже вечернее. Вот. И это есть идея продолжения доклада, пройтись по всем квадратикам, которые мы не успели пройти здесь. Ну, про натив плагинс, что можно сказать, это как раз вот здесь формируется взаимодействие с платформ-чаннелами, чтобы прокидывать их в платформенный поток. Вот, то есть как раз, когда мы с Flutter вызываем что-то нативное. Вот это происходит через вот этот квадратик. Вот. Тут давайте потихонечку подходить к концу. Я думаю, много вопросов должно было возникнуть. Вот. Лучше посвятим время ответам на них. Здесь вот на этом слайде несколько ссылок на статьи, откуда я брал информацию. Вот. Их на самом деле больше, но тут такие основные. Вот. Слайды, я думаю, я скину организаторам, и они пошарят среди всех участников. Вот. Можно будет спокойно посмотреть, но если хотите, можно прямо сейчас сфоткать и быстро глянуть, что там есть. Вот. Тут еще один слайд со ссылочками. Вот. Я его вставлял быстро, поэтому первая ссылка на репозиторий, который не имеет отношения к этому докладу. Он к другому докладу, где я как раз рассказывал про сравнение блок архитектуры с редаксом и MobX и провайдером, и что там я еще, Riverpod я туда запихал, и Qubit. Вот. Ну вот репозиторий — это как раз там небольшое приложение про спикеров конференции, которая реализована 6 разными архитектурами вот этими. Не state management, конечно. Вот, тут ссылочка на мой твиттер и на пару интересных ресурсов, подкастов. Лучше здесь через QR-коды. Вот. Здесь есть подкасты на русском языке, которые как-то касаются Flutter, там интересные темы иногда поднимаются. Flutter Dev подкаст, где мы чисто про Flutter рассуждаем. И второй Mobile People Talks, мы говорим в целом о каких-то интересных вещах мобильной разработки. Там у нас 4 разных ведущих. Один с бэкграундом iOS, один с бэкграундом Android, один с бэкграундом React Native и я со стороны Flutter. И мы там иногда такие холивары устраиваем. Вот. Так что, если будет интересно, да, присоединяйтесь. Ну, я думаю, что можно переходить к вопросам уже.
Да,
Я
спасибо большое,
глаза
Александр.
видел, что их много.
Спасибо большое, Александр. Можно попросить вас на пару слайдов назад мотнуть, там, где у вас ссылки были, потому что как раз Джамшиджан спрашивает по подробной информации.
Ага.
Вот эту страницу оставим открытой, чтобы можно было посмотреть.
Так,
ну, низкоуровневое понимание архитектуры всегда хорошо, да.
Вот просто не так давно, вот та верхняя ссылочка, Inside Flutter, вот она обновилась, то есть очень долго этой информации не было в таком нормальном виде, буквально там, не помню точно, сколько месяцев назад команда Flutter переписала эту статью так, что ее стало удобно читать. До этого было совсем сложно найти инфу. Вот. А сейчас уже прямо на официальном сайте можно все это почитать. Вот. Ну и что тут у нас еще?
Да, ну сейчас я тогда чуть повыше начну. По поводу платформ View. Я так понимаю, чтобы не прямо писать, но, может быть, кратко.
Ну, вот прямо, да, внутри, тут вряд ли я расскажу эти детали, да, но я знаю некую предысторию, как это получилось, что некоторые, сейчас, как бы сказать, как бы изначально такую штуку, как Platform View, делать не очень хотели, потому что неправильно с точки зрения подхода, да, правильно все делать на Flutter. Но, как выяснилось, некоторые вещи делать на Flutter долго, сложно и неудобно, да, в том числе, например, Google Maps. Вот. Она реализована и так под обе платформы нормально, да, и все эти нюансы переписаны на Flutter, там очень бы они устали. И, исходя из этого, решили сделать такой инструмент, как Platform View, который позволяет прямо прокидывать UI. Вот. В этом случае просто там на уровне платформы, то есть происходит прокидывание реального компонента. То есть, по сути, как в React Native работает, да, то есть когда изображение строит не Ski, а строит платформа. Вот. А Flutter просто это дело прокидывает внутрь себя. И, соответственно, взаимодействие между Platform View и Flutter происходит как между платформой и Flutter. То есть напрямую их нельзя контачить. За счет этого там есть некоторые сложности, но и проблемы с производительностью, с перформансом. Поэтому Platform View не рекомендуется к использованию, если можно этого избежать. То есть если только совсем, уже очень много написано, да, переписывать долго, написано под обе платформы, и проще взять и использовать, чем написать это заново. Но будут потери какие-то производительности. Вот.
Но опять-таки это все-таки инструмент, который имеет свои ограничения. Если вам нужно использовать что-то сильно низкоуровневое, лезть в NDK и так далее, то, возможно, стоит подумать 2 раза, прежде чем использовать сам Flutter, если я правильно понимаю.
Ну да. Тем более, если у вас написано там многие компоненты, которые уже очень много чего делают, может быть, на самом деле просто в нативе их оставить. Да? Тем более, если они написаны под обе платформы. Вот, зачем? Flutter же сам как инструмент такой, да, что если у вас как бы много низкоуровневых, да, и индикейных вещей, то, может быть, Flutter не нужен. Ты правильно сказал, да, спасибо.
По производительности.
Угу. Я знаю, что движок на C++, но если сравнить его с Native React, с React Native, да, имеется в виду, кто будет меньше потреблять вычислительной мощности в рендеринг интерфейса? На самом деле есть статья, я не так давно видел, где, даже несколько, где вот напрямую сравнивают на каких-то конкретных кейсах. Вот, берут Native, берут Flutter, берут React Native, делают одно и то же, запускают и с помощью там бенчмарков тщательно замеряют. И расход процессора, и расход, нагрузка на процессор, потребление памяти. Вот. И там, сейчас дай бог памяти, вот, точно выигрыш у Flutter был по сравнению с React Native по нагрузке на память. Вот. По процессору, по-моему, плюс-минус одинаково было. Ну, я, на самом деле, достаточно давно ее смотрел, сейчас боюсь соврать. Проще подглядеть еще раз. Вот. Но ресурс достаточно легко ищется. Если найдете, можно напрямую пингануть, я быстренько их подыщу, потому что я их читал, но так, наискосок. Особо нет. Когда делал статью, не статью, как на работе, когда делал презентацию по сравнению, я тут надергал информации, но это было полгода назад, поэтому не помню сейчас точно.
Но опять-таки это не то же самое, что сравнивать, скажем, игровые движки между собой по производительности. Если мы говорим про клиентские приложения, то, возможно, я бы смотрел в крайнем случае на потребление батареи, если нужно использовать долго. А частенько даже бы, наверное, не смотрел. Сейчас такие мощности в телефонах, что можно и не париться. Я не знаю, какая у вас практика на этот счет по производительности?
По производительности, на самом деле, по большей части Flutter использует, выбирают как инструмент для создания приложений, даже не с точки зрения производительности. То есть вот именно по тому же потреблению батареи раньше были проблемы, да, когда он был сырой. Вот. Много баг было по фикшену, особенно на iOS там были проблемы с этими батарейкой, да, но эти баги, многие были закрыты. Вот. И сейчас, в принципе, там плюс-минус расход на батарею у них одинаковый. Можно, конечно, написать код достаточно кривенько, да, вот, и если не учитывать вот все эти возможности, о которых я рассказывал, когда мы делаем приложение неправильно, когда у нас постоянно происходят перерисовки, то батарея расходуется больше. Вот. И неправильно написанное приложение на Flutter будет сжать батарею, будь здоров. Вот. И если у вас батарея жрется очень сильно, то, возможно, стоит заглянуть в исходный код и что-то оптимизировать. Вот. Возможно, он работает там, где ему работать не нужно. Вот. А вообще, когда происходит выбор там между Flutter, React Native и Native, то тут очень часто запрашиваются больше бизнесовые требования какие-то, именно по экономии ресурсов и получению качественного результата. То есть, когда нужно сделать приложение на несколько платформ, но при этом, чтобы оно было классное, и при этом сэкономить деньги на командах в нативе. Потому что, никуда не денешься, натив, он и в Африке натив, и если есть две классные команды нативных разработчиков, то нативный результат, он написанный персонально под платформу, он всегда будет, как мне кажется, качественнее, чем даже супер классный, написанный на кросс-платформе. Вот. Но Flutter позволяет приблизиться к этому максимально. Но все-таки натив, он остается нативом. Тут никуда от этого не денешься. Вот. Тот же React Native, да, например, его тоже сейчас активно используют, но главным там триггером, как мне кажется, для того, чтобы сделать React Native, тут упирается в опыт и в команду. А если у вас есть команда опытных JavaScripтеров, то, наверное, будет проще сделать приложение на React Native, чем сначала переучить их на Flutter, а потом писать приложение на Flutter.
Так, появился null safety в последней версии. Пора уже переписывать текущие приложения или надо учесть это для будущих разработок?
Они же добавили его пока не в релизе, вот, потому что на самом деле даже сам фреймворк не полностью перейден на null safety. Там он идет, конечно, семимильными шагами, но внутри фреймворка еще очень много частей, которые не используют null safety. Вот. И пока они его не перепишут, в релиз это не выйдет. Вот. Но какие-то части уже переведены. Я смотрел в исходнике, да, там есть уже и required и так далее. Я бы к этому отнесся таким образом. Я отвечу сначала на второй вопрос насчет изменения проектов. Я бы учитывал то, что это скоро будет. Вот. и закладывал это, но не пытался втащить это прямо сейчас, чтобы изменить потом было легко. Вот. То есть, чтобы там параметры, приходящие там в класс, уже проверялись где-то выше, и ты был уверен, что они придут туда там без нала. Вот, и чтобы потом именно этот класс менять бы не пришлось. Вот, а проверки делать там где-то в другом месте, которое потом будет легко поменять. Вот. А почему идет добавление именно сейчас? Ну, смотрите, Dart меняется очень быстро. Да? С тех пор, как появилась версия 2.0, когда он перешел на статическую типизацию, да, с динамической, еще куча там классных всяких изменений, и постоянно изменяется, и немаленькую роль, как мне кажется, в этом играет запрос комьюнити. Комьюнити хочет удобно, хочет современно, вот, хочет как Kotlin, как Swift, вот, поэтому там пришли экстеншены, потому что с ними реально удобнее. И null safety, она же дает удобство. Вот. Почему перешли с динамической типизации на статическую? Потому что так как бы удобнее и безопаснее. Но почему добавили null safety? Потому что так будет удобнее и безопаснее. Почему именно сейчас? Ну, потому что, когда начинали писать, еще об этом не думали.
Или руки не дошли.
Да. А тут мы решили, что пора. Ну, пускай много что написано и будет сложно, но все равно нужно когда-то начинать. И вот сейчас выделили ресурсы на это и начали делать.
Так, ну у нас последний вопрос от Ислама. Сейчас я, наверное, с этого начну. Так,
запускается ли Dart код в бэкграунд или запускается нативный код, который отправляет callback в Dart код? Пытаюсь понять вопрос.
Ну, то есть, когда приложение свернуто, нам нужно крутиться.
Ага.
Ожидать какие-то.
Так. На самом деле, когда у нас приложение сворачивается в бэкграунд, и когда оно вылазит обратно, вот, оно запускается заново. Ну, там есть инструменты для сохранения стейта, вот, но дерево виджетов выстраивается заново. Есть специальные миксины, которые позволяют определять, что виджет создавался заново или создается заново, потому что возвращается из бэкграунда. Таким образом, мы можем это дело проверять. Вот. Но тут какой момент? Dart код и вообще Flutter не может гарантировать свою работу в бэкграунде, потому что там работает платформа, и платформа может взять и как бы кильнуть твои процессы в зависимости от своих необходимостей. Вот. Поэтому какое-то время он может работать, но совершенно бесконтрольно может быть уничтожен. Вот поэтому мы не можем, например, писать сервисы на Dart, да, там какие-нибудь изоляты запускать в сервисах, потому что он могут быть кильнут там в любое время, и мы никак за этим не можем следить. Вот, поэтому...
Да, если вам нужен сервис записать, который крутится, доставайте, расчехляйте NDK в любом случае. Так, и короткий вопрос тоже от него же, от Ислама, как можно ускорить платформу View. Ну, короче, как сделать так, чтобы камера не тормозила, если я правильно понимаю?
Ну, во-первых, зачем использовать Platform View, если мы используем камеру? Мы можем работать здесь через Platform Channel, просто прокидывая видеопоток через стрим. У нас есть такой тип Platform Channel, называется Stream Channel, который позволяет через себя поток пропускать. И мы можем просто брать поток с камеры, направлять его в Flutter и отрисовывать средствами Flutter. И тогда у нас не будет проблем производительности Platform View. Но у нас будет как бы асинхронное взаимодействие просто с камерой. Да. Через Platform Channel это всегда лучше, чем через Platform View. Вот, потому что отрисовка будет вестись с кией. Вот, есть как бы виджеты, которые могут рисовывать видеопоток, вот, и можно тащить этот поток с камеры. Вот. Почему нет?
Так, ну, пожалуй, на сегодня все. Спасибо большое. Как говорится, разрабатывайте свои приложения правильно, да? с учетом того, что под капотом фреймворка, и да пребудет с вами кроссплатформенность и частые релизы.
Если почитать и посмотреть внутрь, как это работает, происходит понимание, как правильно писать. Вот, если ты знаешь, как твой виджет будет обрабатывать, и сколько раз он будет вызываться, и какие методы, вот, ты не будешь меньше писать неправильно, да, будешь понимать, как это взаимодействует. Вот, поэтому это очень полезно знать.
И это касается не только Flutter, это касается вообще любого фреймворка, который вы качаете откуда-то там. Понятно, что вначале нужно попользоваться им, но потом следует залезть и посмотреть, что там все-таки под капотом. Спасибо, что выделили время в воскресенье. Хорошего вам дня.
И вам спасибо, что позвали.
До свидания.
До свидания.
А на этом мы заканчиваем последний на сегодня стрим и последний стрим в рамках нашего трехдневной трансляции. Всем спасибо.